Beyond the outer planets, where sunlight weakens into a pale wash and the interstellar medium begins to murmur, Neptune drifts, blue, cold, and slow. It is the farthest of the gas giants, a planet whose internal heat exceeds the energy it receives from the sun and whose atmosphere shifts with high-speed winds in a paradoxical ballet of motion and cold. For decades, Neptune's faint system of moons has remained in the shadow of its more studied neighbors. Yet in recent years, reevaluation of long-archived data and a handful of targeted telescope arrays have raised a set of questions that resist simple explanation. Neptune's moon system is unusually complex. At last count, it includes 14 confirmed moons. Among them is Triton, a retrograde body believed to be a captured Kuiper Belt object and one of the coldest known objects in the solar system. Triton emits geysers of nitrogen into space and maintains a tenuous atmosphere. But this segment is not about Triton. It concerns the lesser moons, Neso, Halimede, Sao, Laomedea, Psamathe, and others that orbit Neptune at extreme distances and with peculiar inclinations. The outer irregular moons were largely dismissed as inert rocks, gravitationally caught during Neptune's violent past. But this assumption is under re-evaluation, not because of what they reflect in visible light, but because of what they may emit elsewhere. Recent infrared surveys conducted by instruments aboard the Earth-orbiting SPECTRA-X observatory have cataloged faint, warm anomalies trailing several of Neptune's farthest moons. These readings are not consistent with solar heating, nor with thermal radiation from Neptune itself. Some of these bodies are over 100 million kilometers away from the planet, well beyond its magnetic influence or meaningful thermal footprint. The anomalies persist at the same relative orbital positions, suggestive not of background noise or galactic interference, but of something local, something bound. The temperature deltas are small, merely a few kelvins above the cosmic microwave background, but they persist. More unusually, the signature is rhythmic. SPECTRA-X data show that the warmth follows a non-random pulsing pattern, with periodicity that matches the orbital rotation of the moons in question. Initial theories centered around residual internal heat from past tidal heating events. However, such explanations quickly lost traction. These moons are too small, too distant, and too geologically quiet to retain such heat. Others propose that the moons are shedding particulate matter that briefly retains heat, though no visual debris trails have been confirmed. More radical models suggest artificiality, a possibility considered in the margin notes of one of the early analysis papers, later redacted before peer review. The idea is neither fantastical nor new. If a sufficiently advanced intelligence had once seeded outer solar system moons as observational platforms or biospheric preserves, the low thermal output could be a side effect of energy regulation or environmental stabilization. The temperature readings resemble engineered thermal dampening systems found in certain military-grade stealth technology on Earth, designed not to keep heat in or out, but to prevent detection. Further studies noted unusual surface albedos. Neso and Laomedea reflect light in unusual patterns, not due to composition alone, but possibly due to microstructural layering inconsistent with natural weathering. Spectroscopic comparison reveals signatures suggestive of layered carbonates and silicates arranged with nanometric regularity, something only high-resolution observations from the Vera Rubin Observatory revealed in sidelong twilight angles. On Earth, such structuring occurs in synthetic materials and certain biomimetic surfaces. The structure causes light to scatter in restricted directions, reducing diffuse reflection and producing spectral anomalies that mimic thermal nulls. There are no missions planned to visit these outer moons. They are too small, too far, and pose little economic or scientific priority, at least officially. But internal communication leaks from the Neptune Reconnaissance Archive suggest a quiet debate is unfolding within planetary science circles. An interagency meeting between ESA and NASA proposed, under provisional designation Project Lenticular, the possibility of repurposing a future Uranus orbiter for a long-range Neptune flyby, with a remote module designed to release high-resolution radio interferometers into the outer Neptunian system. Such a module would drift silently through space, deploying a tethered sensor mesh near one of the moons flagged by SPECTRA-X. The motivations are not made public. But speculation around the purpose of such missions ranges from defensive monitoring to passive contact attempts. If biospheres exist in the Neptunian periphery, sealed habitats, dormant installations, or radiothermally regulated outposts, they are likely to be non-native to our solar system. Their placement implies a strategic distance, far enough from solar traffic to avoid incidental discovery, yet gravitationally tethered to a major planet to exploit orbital stability. Some observers suggest these moons could be part of a quarantine mechanism, not merely hidden sanctuaries. If they contain life, that life may not be compatible with terrestrial biology or with terrestrial intelligence. The heat pulses may be signaling mechanisms, communicating not across space, but across time, triggered only under specific solar alignments. Others suggest these pulses may not be messages at all, but rather a maintenance signal, keeping dormant systems in equilibrium until a threshold is crossed, possibly one we have already approached with our infrared scans. No confirmation exists. But among planetary researchers, Neptune's moons are no longer regarded as inert rocks. Their rhythms are being watched. The question is not whether they are natural, but whether they are alone. And if they are not, then the secret they keep has waited in deep freeze longer than human civilization has existed. When astronomers look across the immense spans between galaxies, they observe not just the light of stars, but also the subtle signatures that light leaves behind. In the infrared spectrum, galaxies often reveal secrets invisible to the human eye. The glow of warm dust, the quiet burn of star formation, and on rare occasions, anomalous brightness that exceeds the expected thermal output. This excess, persistent and distinct, has long intrigued astrophysicists. It is in these infrared surveys that the question of Dyson-like structures arises, not as wild theory, but as a matter of observational anomaly. In theory, a Dyson sphere, a megastructure encompassing a star to harness its energy, would absorb visible light and re-radiate energy in the infrared. A complete sphere would be unstable and unnecessary. More likely, advanced civilizations would construct Dyson swarms, vast fields of orbiting satellites collecting energy. These would emit waste heat in the mid-infrared spectrum, peaking at wavelengths detectable by Earth-based and orbital infrared telescopes. The Wide-Field Infrared Survey Explorer, WISE, and later missions like Spitzer and JWST have identified candidate galaxies with suspiciously high mid-infrared output. Some show no signs of active starburst, no recent mergers, and no abnormal dust content. Yet, they glow in the thermal infrared as though an internal furnace has been lit. One candidate, cataloged as IRG 1089, located over 3.2 billion light-years away, exhibits an infrared luminosity inconsistent with stellar population models. Its visible profile is dim and unremarkable, a faint elliptical smear. But in the mid-infrared, it brightens with surprising symmetry, The radiation curve follows a blackbody profile centered around 300 Kelvin, a temperature cooler than a star but warmer than ambient galactic dust. A galactic civilization utilizing Dyson swarms would reprocess stellar energy into useful work, but the second law of thermodynamics ensures no energy use is perfectly efficient. The waste heat must go somewhere, and it is this unavoidable thermal signature that becomes the beacon, accidental but impossible to mask completely. Critics argue that natural processes can mimic these signals. Obscured active galactic nuclei or complex star-forming regions with layered dust shells can produce similar thermal profiles. However, statistical analysis reveals that a subset of these galaxies diverges from known thermal templates. They cluster within a narrow temperature band, exhibit minimal variance across time, and often reside in regions of space relatively devoid of other galactic activity. The implication is not that these are conclusive evidence of megastructures. Rather, they are outliers that defy current modeling, anomalies that remain even after accounting for cosmic dust, background radiation, and instrumental noise. Some researchers propose a Type II leakage model, in which small clusters of stars within a galaxy are partially enclosed by energy harvesting systems, perhaps for industrial purposes or climate regulation. These would still glow, albeit faintly, in the infrared. Attempts to follow up with spectroscopic analysis using JWST have returned ambiguous results. The signal is weak, diluted by intergalactic dust and time, yet consistent across multiple observing runs. A research team from Kyoto University proposed launching a free-flying interferometer chain, thousands of microsatellites positioned to create an artificial infrared aperture the size of the Moon's orbit. Their proposal remains theoretical, but its goal is direct: to determine whether the symmetry of the infrared glow corresponds to engineered geometry. No clear answer has yet emerged. But the sky is no longer silent in the wavelengths we once ignored. Every scan adds new dots to the map, new questions to the ledger. Somewhere among them may be the first whisper of an intelligence not only capable of harnessing stars, but disciplined enough to leave behind only heat. In the inner Oort-like zones of our solar system and the asteroid-rich corridors between Mars and Jupiter, impact craters are among the most common geological features. Their shapes are familiar, their mechanisms well understood. High-velocity collisions leave behind depressions, shock fractures, and ejecta blankets. So when a planetary body registers a high-energy event without a crater, the absence itself becomes an anomaly worth investigating. Planetary body 29075, a mid-sized trans-Neptunian object discovered in 2009, recently entered scrutiny after archival thermal data and long-range imaging revealed a curious feature: a sudden increase in localized surface albedo across a broad, flat region without corresponding signs of structural displacement. The event, estimated to have occurred between 2017 and 2018, was first noticed by researchers parsing through data from the Deep Horizon Survey Array. A wide-field scan captured the object's surface over time, revealing a stark shift in reflectivity along a roughly circular area over 40 kilometers in diameter. Craterless impact zones are not entirely unknown, but they are rare. In most models, an impactor strong enough to deposit high energy and cause a material transformation would inevitably leave behind subsurface scarring or disrupted terrain. On planetary body 29075, none of this exists. The area remains unnaturally smooth, its temperature signature stabilized, and with only minor fluctuations consistent with ice outgassing. The surface's optical profile changed. Before the event, the region reflected light in scattered, granular patterns typical of dirty ice and regolith mixtures. After the shift, the reflectivity increased in a way consistent with vitrification, when silicate material undergoes extreme heat and then rapidly cools into a glassy state. Yet the region in question lacks the kinetic traces of an impact or explosive melt. There is no ring of elevated terrain, no ejecta field, no microfracturing. Instead, the reflective layer seems to have been laid down evenly, as though by a thermal wave or directed beam. Spectral analysis shows microcrystalline alignment in hexagonal arrays, reminiscent of certain controlled high-temperature lab processes. This structuring is implausible through natural means on a low-mass body with no significant atmosphere or internal activity. Further anomalies arise in the magnetic field readings. Planetary body 29075, like most objects of its kind, was presumed magnetically inert. But instruments aboard the long-range observatory Aphelion 9 detected residual magnetic gradients near the vitrified zone. These are subtle, fractions of nanoteslas, but spatially coherent and radial in pattern, like the weakening aftershock of a precise directional magnetic pulse. Some researchers suggest a non-collisional mechanism, an energy-based event from outside the body itself. In other words, a targeted burst, perhaps a scanning technology, a mining attempt, or something more obscure. The energy appears to have restructured the material without physically displacing it. On Earth, similar patterns appear in experiments involving laser-induced surface crystallization, where focused energy aligns molecules without destructive force. Alternative explanations invoke cryovolcanism, or rapid phase change events. But simulations repeatedly fail to reproduce the specific thermal signature, the smooth reflectivity, and especially the lack of terrain disruption. The evidence does not fit the profile of geological activity, and certainly not of any known impact process. The idea of deliberate alteration becomes difficult to avoid. If the event was caused by technology, ours or otherwise, then it represents a level of precision and energy application beyond current human capability at that distance. No known probes visited or passed near 29075 during the window of the event. No classified missions, as far as public records indicate, operated in that orbital corridor. Some have proposed the possibility of inertial calibration. That is, the event may have been a test of long-distance energy projection, a probe or instrument attempting to fire from afar to calibrate timing, aim, or focus. The target? A small, stable, geologically inactive body, ideal for observing the unambiguous results of interaction. If so, planetary body 29075 may have served as a cosmic slate, clean, distant, and quiet. Whatever occurred there, it left a mark not of violence, but of precision, a mirror on a rock, a signal perhaps, or a test. The region continues to hold its unusual optical properties to this day. Its infrared emissions remain subdued but steady, like a faint echo. And yet no other anomalies have appeared on its surface since. No follow-up activity, no secondary events. Just the one circular zone, shimmering faintly in sunlight, waiting in silence. High above the lunar equator, in the plateau regions along the moon's western limb, ancient telescopic surveys occasionally report fleeting flashes, transient lunar phenomena. Most are dismissed. Micrometeorite strikes, outgassing events, reflections from Earth's surface, but in 2023, a series of observations from a synchronized triad of orbital satellites documented something harder to explain. In a stretch of rugged terrain just west of Mare Imbrium, near the collapsed lava tubes of Sinus Iridum, A set of faint reflections was recorded that could not be traced to surface topology or albedo anomalies. These reflections, appearing only under specific lighting angles during lunar twilight, took the form of semi-parabolic arcs, each with a reflectivity pattern suggesting a highly smooth surface. More strikingly, the reflections demonstrated consistent spatial orientation, despite differing orbital perspectives. This ruled out random rock faces and strongly suggested a curvature not caused by natural erosion. The working hypothesis emerged: partial dome-like structures made of a highly reflective material embedded beneath a thin regolith cover. Their appearance is not constant, visible only when the sun hits the region at low angle, and only for minutes at a time. This makes replication difficult, but across dozens of passes, a consistent geometry emerged. The shapes were concave, overlapping slightly, and oriented toward the ecliptic. Lunar surface scans from past missions, including Clementine and LRO, were reanalyzed. No significant radar anomalies had been noted in that region, though in several datasets, faint microwave absorption patterns did match the outlines of the proposed dome structures. Unlike rock, the surface beneath the regolith here absorbs microwave radiation unusually efficiently, suggestive of layered composites or cavity structures. Aerospace engineers examining the patterns proposed that the formations could resemble partial tensile domes, structures relying on surface tension and internal support to maintain shape. Such architecture, if synthetic, would offer resistance to meteorite impact and radiation exposure, and could theoretically house equipment, environmental controls, or biological systems. But the age of the site is unknown. No seismic activity suggests recent construction. No thermal fluctuation points to active systems. The domes, if they exist, appear inert. Some researchers floated a more radical hypothesis that the structures are ancient and possibly damaged. Their partial exposure may be accidental, perhaps triggered by a localized collapse or surface event in recent decades. The reflectivity, then, is a side effect of degradation. Others suggest the domes were never designed to be hidden, that their appearance in twilight may be intentional, a signal readable only at the right moment, from the right angle. Skeptics counter that no known probes have encountered reflective debris or structural remnants in nearby regions. No surface rover missions have approached the coordinates, but the lunar far side, and even parts of the near side's northern reaches, remain largely unexplored on foot. Private aerospace firms, including those involved in next-generation lunar mining, have expressed interest in the region, not because of the domes themselves, but because of the microwave absorption patterns, which could suggest rare subsurface minerals or previously overlooked voids ideal for development. Whether this will lead to direct investigation remains unclear. For now, the glassy arcs remain a mystery. They do not pulse, they do not move, they reflect faintly and only briefly, as though waiting to be noticed, but only by those who know when and where to look. Among the many frameworks for explaining the Fermi paradox, the zoo hypothesis is one of the most philosophically provocative. It suggests that Earth and its inhabitants are being deliberately avoided, quarantined, observed from afar, or cordoned off from galactic civilization. The theory typically evokes the image of Earth as a natural preserve, where external contact is forbidden until certain criteria are met. Yet, in recent years, a subset of this framework has evolved into what some theorists are calling the quarantine orbit theory. The hypothesis focuses not on planetary surfaces, but on orbital mechanics. Specifically, it considers the distribution and absence of artificial bodies, satellites, megastructures, or anomalous orbital objects, within specific orbital shells of habitable planets. Earth's orbital space, it notes, is conspicuously devoid of certain types of repeating phenomena that might suggest observation or containment. The theory argues that if extraterrestrial civilizations have the means to manipulate or avoid contact, they may do so not from planetary surfaces, but from highly specific orbits, those optimized for long-term surveillance or isolation enforcement. In examining our own solar system, theorists point to the peculiar distribution of minor bodies and orbital resonances. In Earth's orbital vicinity, for example, objects like 2010 TK7, a Trojan asteroid following Earth's orbit in a gravitationally stable point, are extremely rare. Other planets, such as Jupiter and Neptune, have multiple Trojans. Earth does not. If Trojan points are ideal for discrete orbital platforms, why are Earths so underpopulated? Beyond this, models of long-duration satellite coverage show that orbits above 36,000 kilometers, geosynchronous and beyond, offer stable platforms for observational systems that could, in theory, monitor the entire planet indefinitely. These orbits have been utilized extensively by human satellites, but searches for unexplained objects in these altitudes have come up largely empty. A small number of dark satellites have been detected, bodies that reflect almost no visible light and transmit no known signals, but none have shown consistent orbits or behavior over time. The Black Knight satellite myth, often cited in fringe literature, is regarded with skepticism by the scientific community, though it is occasionally referenced in quarantine orbit discussions as a symbolic case study. The question arises, if Earth is under quarantine, where are the quarantine mechanisms? Theorists suggest that quarantine, or its observational cousin, need not be enforced physically. It could be informational, electromagnetic, or psychological. For instance, certain high-altitude orbital bands may be shielded or distorted via gravitational lensing techniques, masking the presence of structures or devices. Alternatively, the absence of anomalies may itself be engineered, our skies meticulously edited to appear void of artificial intrusions. This line of thought gained traction following a controversial study by the Kepler Data Review Group, which found subtle statistical anomalies in long-term light curves of specific orbital angles near Earth. The variations were too slight to register as objects, but consistent enough to suggest periodic occlusion, something passing through the line of sight with extreme stealth characteristics. These were initially dismissed as instrumental artifacts, but have since become a touchstone for those exploring the quarantine orbit theory. If such systems exist, they may not be intended to block us from seeing out, but rather to prevent others from seeing in. Earth could be part of a larger network of protected biospheres hidden behind camouflage or cloaking technologies until its civilizations reach a predefined threshold of awareness or stability. Alternatively, the absence of interference may be the result of a warning protocol, an indication that humanity is considered volatile or unpredictable, and therefore best observed from a distance. Other planetary systems provide points of comparison. Several exoplanets with known biosignature markers exhibit orbital patterns that seem too clean, lacking debris belts or having unusual regularities in their transit timing. Some researchers have proposed that these sterile orbits may be the result of artificial intervention designed to minimize cross-contamination between developing biospheres. Under the quarantine orbit theory, Earth is not alone, but it is isolated. Not because we are unworthy of contact, but because contact itself may be forbidden under interstellar governance systems we have yet to detect, much less understand. It is a theory without proof, supported only by the shape of absences. But absences, too, have form. In the silence above there may be structure, in the empty orbits, intention. Europa, one of Jupiter's largest moons, is a world of ice and suspicion. Beneath its frozen crust lies a global ocean, kept warm by tidal flexing from Jupiter's massive gravity. For decades, Europa has been a leading candidate in the search for extraterrestrial life, not because of what it shows, but because of what it hides. But in recent observations from the high-sensitivity instruments aboard the Cryolume Array, a network of orbiting telescopes calibrated for extreme low-light detection, a new mystery has emerged. During a series of long-duration exposures taken while Europa passed through Jupiter's shadow, observers detected faint grid-like bioluminescent patterns on the moon's night side. These patterns were not random. They formed geometric configurations, long lines of even spacing intersected by perpendicular paths with sharp right angles and repeating intervals. The intensity of the glow was extremely faint, just above the threshold of detection, and only visible in the far blue end of the spectrum. Initially assumed to be imaging artifacts or cosmic ray noise, the signals persisted across multiple exposures and were confirmed by at least 2 independent observatories. More tellingly, the patterns shifted subtly over time. The lines moved laterally, maintaining their orientation while changing position, like a slow drift across the surface. This rules out simple cryovolcanism or ice cracking, which are chaotic and irregular. The consistent geometry and movement suggest either an organized biological process or something artificial. Some marine biologists drew analogies to deep-sea bioluminescent organisms on Earth, which display coordinated signaling behavior, whether for mating, navigation, or schooling. Yet the scale here is orders of magnitude larger. The glowing grids extend for kilometers. If biological, they would require massive, coordinated colonies of organisms, possibly living within the ice just below the surface, responding to the changing pressure or electromagnetic signals. Alternatively, the patterns could be energy emissions from structures embedded in the ice. If they are technological, they may be a kind of passive communication, a visual system designed for observation from orbit rather than broadcasting to space. Interestingly, the grid formations follow the stress lines of Europa's icy crust, as mapped by previous missions. This may imply that whatever produces them, organic or synthetic, favors areas of natural weakness or permeability. It is as though the structures or organisms are working with the moon's geology, not against it. ESA's planned Clio 2 mission includes a close pass over the affected regions. Instruments on board are designed to detect thermal gradients, electromagnetic variations, and chemical markers associated with metabolic activity. If the patterns are active again during the mission's window, it may provide the first close-range data of their composition. The implications remain speculative. The signal could be biological, emerging from an evolved form of cryophilic life adapted to the moon's extreme environment. It could be a form of primitive bioelectronic communication, like synapses spread across kilometers of ice. Or it could be technological, representing an active or dormant infrastructure embedded in the crust. For now, the glow remains, faint, slow-moving, and eerily geometric. Not enough to answer questions, but more than enough to ask them. Mercury, the innermost planet of the solar system, is often overlooked in speculative discussions. With no substantial atmosphere, no magnetic shielding to speak of, and a surface scorched by intense solar radiation, it appears barren, hostile, even to robotic observation. Yet it is precisely this unforgiving exposure that makes Mercury a peculiar point of interest in the study of orbital and surface anomalies. In particular, a series of recurring artificial-looking shadow patterns recorded near the planet's polar regions has reopened debates on whether all is as inert as it seems. The discovery began with the Aegis Surveyor mission, an unmanned probe launched in the 2030s with the aim of refining Mercury's gravity maps and magnetic field models. Equipped with advanced LiDAR and multispectrum imaging tools, it passed repeatedly over the northern pole where permanently shadowed craters, regions never touched by sunlight, preserve frozen volatiles, including water ice. On several passes, Aegis recorded transient shadow formations across crater walls that did not align with topography, solar angles, or expected geomorphology. These shadows manifested briefly, always in the same configurations, always during very specific solar declinations. Unlike the jagged silhouettes of rocks or ridgelines, these patterns were geometric, intersecting lines, ovals, and symmetric loops that appeared static across multiple orbits, but vanished outside of the designated viewing windows. The patterns were initially dismissed as contrast errors or thermal blooming in the sensors. However, ground-based simulations using topographical models failed to replicate the shadows. Even under extreme variations of solar incidence and imaging angle, the formations could not be matched. They remained anomalies, but their recurrence drew attention. A subsequent pass using an alternative imaging mode tuned to ultraviolet reflections recorded faint spectral traces emanating from the same regions, specifically at the edges of the anomalous shadows. The spectral profile was unusual for Mercury's surface. It lacked the typical signatures of regolith, scattering, or silicate resonance. Instead, the UV reflections matched high albedo surfaces with embedded metal oxides, compositions closer to manufactured coatings than natural crustal material. The speculation escalated further when thermal readings of these same crater walls showed faint but measurable heat differentials at night. The areas warmed and cooled in a pattern not aligned with natural radiative behavior. One hypothesis suggests the presence of internal cavities or thin films, possibly reflective or absorptive layers beneath the surface that influence local thermal conductivity. If these features are artificial, their purpose remains obscure. One school of thought suggests passive markers, visual or thermal patterns that function as long-term calibration systems, visible only during rare alignments. Another proposes they are part of a communication system, not directed at Earth but serving as some form of interplanetary timing signal encoded through visibility thresholds. The artificial shadow patterns could be, in essence, glyphs, messages written not in text, but in timed geometry and contrast. A third theory suggests these structures, if indeed real, may serve as concealment or cloaking mechanisms. On a planet where the environment naturally destroys most evidence of past activity, shadow patterns may be the only viable way to preserve information across geologic time. Critics of the theory argue that Mercury's harsh conditions preclude any long-term structure, artificial or otherwise, from surviving unaltered. Yet others point to that very extremity as a possible motivator. If an ancient intelligence wished to place a message or a mechanism somewhere durable, Mercury, with its lack of weather, low seismic activity, and orbital predictability, would be a candidate. Not hospitable, but stable. Plans are underway to revisit the polar regions in future joint ESA-JAXA missions, which may include low-altitude radar mapping to detect subsurface cavities or irregular layering. However, for now, the shadows persist as digital ghosts, appearing only in the narrow corridors of light and angle, then disappearing again into silence. Mercury's poles remain untouched by sunlight. but perhaps not untouched by intention. Encircling Saturn like spectral halos, the planet's rings are one of the most iconic features in the solar system. Comprised mostly of water ice, dust, and rocky fragments, they extend hundreds of thousands of kilometers, yet remain just tens of meters thick. These rings, dynamic and delicate, are not uniform. Their gaps, braids, and density waves suggest an underlying complexity, gravity shepherded by Saturn's moons and shaped by unseen processes. Within this intricate system, a peculiar anomaly was logged during the tail end of the Cassini mission. A narrow-band radio signal detected only briefly, emanating from within the B ring, a dense, relatively opaque section of the ring plane. The signal, designated Relay 7V, was found in archived magnetometer data hidden within electromagnetic noise. It had a repeating modulation not consistent with any known natural resonance or lightning-induced emission. Relay 7V was characterized by a narrow frequency envelope centered around 42 kHz and exhibited a faint but repeating triplet tone spaced by 1.73 seconds. Though it lasted only 42 minutes, it repeated again in a similar region 13 days later, but never again after that. At the time, this was considered a fluke, possibly a product of electromagnetic interaction between Saturn's magnetosphere and dust grain alignment. But upon retrospective analysis, several patterns emerged. First, the timing matched a resonance cycle between the moon Prometheus and a specific ripple in the B-ring density wave. Second, the signal's timing matched the orbital window of Cassini's low-gain antenna calibration sweep, suggesting a potential reply or reflection. These coincidences led to the Saturn relay hypothesis, that the signal may not be random, but an echo or even a failed communication attempt from an object embedded within the rings. Rings are not typically thought of as hiding places, but their constantly churning material, high reflectivity, and dense masking effect make them perfect for concealing transient or small-scale structures. If something technological had been placed within the ring plane, a probe, a beacon, or a passive relay, it could operate for centuries undetected. The ring material would naturally erase traces of entry and mask low-power emissions. Supporters of the relay hypothesis note the strange behavior of propeller features, localized distortions in the ring caused by embedded moonlets. One of these, cataloged as B12X, showed erratic acceleration patterns over several orbits, behaviors inconsistent with gravitational models and not accounted for by known material interactions. During one of these anomalies, a brief broadband signal spike was recorded, overlapping with a moment of peak density flux in the surrounding ring matter. Critics point out that Saturn's rings are too unstable for permanent installations, and that any embedded probe would require periodic correction to maintain position. But that challenge may be surmountable by advanced technology, especially if its purpose is not to remain indefinitely, but to act as a transient repeater or signal redirector, a relay system meant to function only intermittently. The question remains, who or what would need such a system? The hypothesis does not assume intentional contact. It may be a remnant of past surveillance or interstellar navigation infrastructure, long dormant until disturbed by a passing probe. Efforts to triangulate the signal's origin were inconclusive. Cassini's orbit was not optimized for tight directional detection at those frequencies. And with no further probes currently active around Saturn, the mystery remains frozen in telemetry. The rings continue to rotate, their particles colliding, reshaping, smoothing over all that passes through. If something ever was there, it may already be gone. But the signal, brief, rhythmic, and inexplicable, persists in data. a whisper across ice and vacuum, a forgotten node in a forgotten network. Within the veiled star-forming regions of our galaxy, stellar nurseries where dense clouds of dust and gas give rise to new suns, astronomers have occasionally recorded more than light. Using sensitive radio and audio frequency instruments, researchers have picked up repeating acoustic-like modulations embedded in electromagnetic data. These are not sound in the traditional sense, since space lacks a medium to carry it. Instead, they are oscillations within radio emissions, converted into audible frequencies during analysis, patterns that resemble structured tones or rhythmic pulses. These regions, such as the Eagle Nebula's Pillars of Creation or the Serpent's South Cluster, are expected to produce broad-spectrum radiation. The process of stellar ignition, shock waves from young stars, and magnetic reconnection events all generate chaotic signals, but some anomalies show temporal symmetry, pulses separated by precise intervals, often nested in triplets or repeating logarithmic scales, structures found in music, language, and engineered signaling systems. One particular case, observed in 2031 by the Perseus Sweep Array, focused on a star-forming complex 7,000 light-years away. During a 34-hour observation window, a narrow-band signal was detected with a rising chirp pattern, repeating every 11.2 minutes. The source, located in the densest part of a Bok globule, a compact, opaque pocket within the cloud, displayed no visible star or protostar, only heat signatures consistent with early gravitational collapse. This alone was unremarkable. But the audio profile, once rendered into sound for spectral analysis, bore an uncanny resemblance to modulated sonar. It wasn't the pitch or tone that caused concern, but the dynamic range and interval regularity, attributes absent from any known astrophysical process at that stage of star formation. Initial reaction was cautious. Suggestions ranged from plasma oscillations in magnetic fields to coincidental harmonic reflections in the telescope's instrumentation. A follow-up study used 3 independent arrays in widely separated Earth orbits to triangulate and confirm that the signal was real and external. Some researchers speculated that the repeating patterns could be a natural byproduct of turbulence as stars condense. Yet attempts to reproduce the audio patterns in simulations failed. Even when accounting for dust interference and chaotic magnetic fields, the regularity of the signal could not be replicated. More speculative minds suggested that the audio-like signals might represent attempts at signaling through indirect means. That is, rather than emitting direct communication beams, an advanced intelligence might exploit naturally occurring star-forming regions to embed low-frequency modulations, encoded into the radiation emitted during gravitational collapse. These would be detectable only under specific alignments, only by civilizations advanced enough to recognize structure in chaos. This nebular encoding theory holds that certain regions of space could act as distributed recorders or beacons, not physical devices, but spatial configurations tuned by previous manipulation. If so, they might function similarly to acoustic holograms, information embedded in interference patterns, requiring only the right observational context to unlock. Critics dismiss this as an exercise in pareidolia, arguing that human brains are adept at detecting patterns, even where none exist. Yet the signal's numerical characteristics persist. Time intervals, precise to within milliseconds across a dozen repetitions, amplitude decay that follows an inverse exponential function, and a harmonic substructure with integer spacing. These are not features of turbulence. They are features of encoding. To date, no repeat signals have been found in that same globule. Other stellar nurseries are under observation, but results remain inconclusive. The cosmic noise floor is high. But the whisper was there, brief, structured, and local, to a place where no star had yet fully formed. Perhaps it was nothing, a coincidence of matter and magnetism. Or perhaps, hidden in the birthplaces of stars, there are messages left not in words but in the fabric of light itself, messages that only the curious and the quiet will ever hear. On the red plains of Mars, much of the surface erosion is attributed to wind and seasonal frost. The Martian atmosphere, though thin, can still move fine dust with surprising force over centuries. But not all features on Mars are so easily explained. Along the fractured edges of Valles Marineris and the cliff walls of Hebes Chasma, orbital imagery has documented geometric formations etched into the rock, shapes that resist geological classification. These formations are not symbols or pictographs. They are angles, regular, precise, and unusually spaced. And, using high-resolution imaging from the Mars Context Camera, analysts mapped over 200 instances of polygonal etchings along cliff faces, most located within 30 degrees of the equator and primarily oriented perpendicular to the planetary crust. Unlike natural polygonal fracture patterns, such as those found in dried mud or basalt cooling columns, these angles are not the product of tensile stress. They occur in vertical walls, often in layers not aligned with sedimentary bedding, and show no correlation with mineral composition. More intriguingly, they are arranged with exact spacing, frequently in increments of 2.5 meters, with deviations of less than 5 centimeters. For natural erosion, such precision is anomalous. Initial interpretations suggested mass wasting events or ancient landslides, but simulations failed to reproduce the angular regularity. Additionally, spectral analysis revealed that the etched areas possessed slight discolorations, consistent with the presence of carbon compounds not found elsewhere in the surrounding matrix. These compounds were not organic in the terrestrial sense, but rather complex chains indicative of synthetic carbon bonding, similar to polymerized surfaces used in human aerospace insulation. Some formations exhibit right-angle cuts at depth, visible only under oblique sunlight. Others are recessed into the cliffside, forming square alcoves or triangular indentations. They cast shadows too crisp to be random and align with each other across vertical distances of over 60 meters, implying a common geometric framework. The prevailing hypothesis is that these formations may be the remains of anchoring structures, possibly for long-gone platforms or habitat systems embedded into the cliffs. If so, they would represent an engineering solution. Use the canyon walls for protection from radiation and impact, with internal chambers extending laterally into the rock. Skeptics argue that no debris or detritus is found near the formations. If structures once existed, why is there no trace of collapse? But this assumes the same materials and decay timelines as human technology. If the constructions were self-consuming, retractable, or biologically integrated into Martian geology, then their disappearance might leave only the anchoring geometry behind. There is also the question of distribution. The etchings occur only within narrow altitude bands, never near the base of the chasms, never at the highest ridgelines. They follow the solar ecliptic in orientation, as though designed to maximize sunlight exposure at equatorial latitudes. Speculation remains tentative. Future Mars missions, particularly those deploying autonomous climbing drones or tethered mapping crawlers, may explore the vertical faces more closely. Current rovers cannot reach the cliffs. Until then, the angles remain not symbolic, not decorative, just geometry, clean, precise, and wrong for the wind and dust that surround them. A math that does not match the chaos. A trace of order where there should be none. In the vast and silent cosmos, neutrinos are among the most elusive messengers. They pass through matter almost unaffected, barely interacting, and are produced in abundance during supernovae, nuclear reactions, and the decay of certain fundamental particles. Over the past few decades, vast underground detectors like IceCube in Antarctica and Super Kamiokande in Japan have mapped the arrival of these ghostly particles with increasing sensitivity. Most neutrinos arrive as a steady background hum, a whisper of the universe's deep processes. But in 2036, a pattern began to emerge, one that did not conform to randomness. Every 11.3 days, a high-energy burst of neutrinos was detected, each arriving from the same fixed set of celestial coordinates just outside the plane of the Milky Way, near the constellation Sculptor. The pattern continued for over 6 months, precise in timing, narrow in arrival angle, and consistent in energy range. These were not supernova neutrinos, nor byproducts of gamma-ray bursts. Their energy profiles were too uniform, and no corresponding electromagnetic events were observed in tandem. The detections sparked immediate interest. At first, the hypothesis centered around an unknown binary system emitting neutrinos via exotic decay processes. But no stellar object was located at the origin point, not even a white dwarf or neutron star remnant. Optical, infrared, and X-ray surveys of the region revealed nothing unusual. It was dark, completely so. Further analysis ruled out atmospheric or instrumental interference. The arrival directions were confirmed by detectors on opposite sides of Earth, sometimes even triangulated via deep space observatories stationed at the Earth-Sun Lagrange points. The signature was genuine, the source fixed. Then the intervals between bursts began to change, not in an erratic way, but with a slowly increasing delta, as though part of a countdown or progressive algorithm. The interval extended to 1135 days, then 1142, then 1155. Each successive cycle slightly longer than the last. The energy levels, however, remained constant. Physicists began to consider more exotic causes. Could this be an artificial signal? Unlike electromagnetic waves, neutrinos pass through nearly everything, meaning they could serve as long-distance carriers immune to signal degradation or obstruction. On Earth, we have barely begun to explore this capability, but an advanced intelligence might have mastered neutrino communication as a stealthy, nearly undetectable method of interstellar messaging. The repeating neutrino bursts could thus represent a ping, a beacon. Perhaps not directed at Earth, but sweeping the sky in rotational arcs, checking for detection or response. Alternatively, the signal may not be communication at all, but telemetry, status updates from a distant probe or system encoding data in a neutrino stream. The lack of modulation, however, suggested minimal information content, unless the encoding system itself operates in a form not yet deciphered by human observers. One researcher from the University of Helsinki proposed that the signal might be a synchronization pulse used to align distant systems across light years of space, like galactic metronomes. If so, Earth may simply be in the path of one such sync beam, its presence entirely incidental to the larger mechanism. A more unsettling theory suggested the opposite, that Earth has entered a detection phase. The bursts are not messages, but scans. Probing signals sweeping across the galaxy at fixed intervals, measuring for neutrino absorption or return flux, looking not for recipients, but for anomalies, signatures of activity, of deviation, of presence. Whatever the case, the signal began to weaken by the end of 2037. The final confirmed burst was detected in January 2038, after which the pattern ceased entirely. no further neutrino pulses from the same coordinates have been observed. The sky returned to silence. What remains is the data, precise timestamps, arrival angles, energy profiles, all captured and preserved. The origin remains unknown, no mass, no light, just a dark coordinate in space that for a time pulsed like a heartbeat across the void. Exoplanet YZ Ceti D orbits a red dwarf just 12 light-years away, making it one of the closest known Earth mass planets. It completes one orbit every 2 days, locked in a tight, blistering rotation that bathes one hemisphere in constant starlight. From afar, it appeared unremarkable, a rocky world likely stripped of atmosphere by stellar flares. But in 2035, high-contrast imaging from the Lagrange Horizon Array revealed a silhouette near the planet, an irregular moon, orbiting erratically with an inclination that defied orbital mechanics. Unlike most natural satellites which settle into equatorial orbits through tidal forces, the moon of YZ Ceti D, designated temporarily as D1, exhibited a precessing trajectory. Its path wobbled with high eccentricity, completing a chaotic loop every 14 orbits. But it wasn't the motion that drew attention, it was the shape. D1 is not spherical, nor ellipsoidal. It appears flattened on one side, jagged on another, with angles that suggest artificial geometry. When rendered from imaging data, the moon resembles a skewed tetrahedron, with flat facets that reflect light with disproportionate intensity relative to its apparent size. More perplexing are the reflectivity curves. Observed over 800 hours, D1's albedo fluctuates in a narrow band, but always in sync with the rotation of YZ Ceti D. When the planet's sun-lit side faces Earth, D1's reflections drop to nearly zero. But when the night side faces us, D1 brightens, glinting briefly in wavelengths, consistent with directed emission rather than passive reflection. If this effect is deliberate, it suggests D1 may be synchronizing its emissions with the planet's dark side, possibly to transmit or receive without interference from stellar activity. In other words, D1 may be performing surveillance or communication while hiding from both its star and external observers. A technique akin to optical stealth. Speculative papers have proposed that D1 is not a moon in the traditional sense, but a platform, either in geosynchronous orbit or tethered via magnetic coupling to the planet's ionosphere. Its irregular motion could be deliberate, a combination of orbit and propulsion, with corrections made invisibly between observation windows. Spectral readings offer more hints. Across multiple epochs, spikes in polarized light have been recorded, consistent with rotating solar panels or phased array emitters. These spikes do not correlate with any known natural mineralogical surfaces. Instead, they suggest moving components, elements that alter reflectivity in repeating but non-sinusoidal patterns. Attempts to listen for radio signals from YZ Ceti D and its vicinity have yielded only background noise. But during one synchronized observing run in 2036, a faint narrowband signal lasting 0.8 seconds was recorded when D1 passed between the planet and its star. It was a descending tone sweeping from 1.1 GHz to 0.9 GHz, with harmonic ripples trailing behind it. No repetition has since been observed. Some argue that D1 could be a remnant, a derelict station long abandoned, now in a state of passive drift. Others see it as active, possibly maintaining observation of YZ Ceti D's surface, or projecting influence downward, in a way not yet understood. Still others propose a third possibility, that D1 is not of the same origin as the planet it orbits, that it was placed there long ago for reasons unrelated to the host system. D1 remains visible only to our most sensitive instruments. Its motion, its shape, its silence, all raise questions that cannot yet be answered. But if moons tell stories, this one does not speak of natural formation. It tells of placement, of function, of purpose withheld. Across the cosmos, certain objects resist categorization. They are not stars, not planets, not asteroids, nor black holes. They flicker into view under only the most precise conditions, through rare alignments, in wavelengths we rarely observe, or only in data revisited years later. One such anomaly emerged in 2040 during a full-sky gravitational microlensing survey conducted by the Trans-Lume Array, a system of interferometric telescopes spread across lunar orbit. The event was subtle. A background star briefly brightened, not once, but twice, over a 22-hour span. This alone would not be unusual. Gravitational lensing, where massive bodies bend and amplify light from objects behind them, is a well-understood phenomenon. But the double peak in the brightness curve raised immediate suspicion. Normally, a single micro-lensing event produces a smooth arc of increased luminosity as the foreground object crosses the line of sight. But this event displayed two symmetrical peaks with an abrupt drop between them, a dip that remained perfectly flat for 3 full hours. This plateau defied all known gravitational lensing models. There was no gradual fade, no trailing scatter. It was as though the foreground object had a hollow core, a perfectly dark, non-lensing interior. Further analysis showed the lensing object's mass to be approximately that of a small moon, yet there was no known mass concentration at the coordinates, no infrared source, no reflected light, no X-ray activity. It was, in every sense, invisible, except for its influence on the light behind it. The prevailing hypothesis formed quickly. This was not a natural body, but a structure, a hollow or non-uniform object with sharp internal boundaries capable of distorting gravitational fields in ways that suggest angular, non-spherical mass distribution. Some theorists proposed a toroidal configuration, a ring-like mass that could explain the twin peaks and the flat central gap. But natural toroidal objects at this scale are unheard of. One paper, published quietly through a university in Prague, suggested a more exotic idea, a cloaked observation post designed to use gravitational lensing to survey background stars without being observed itself. The lensing event, then, was a malfunction, a deviation in orbital trajectory that momentarily brought the object into alignment. It had blinked into visibility by accident. To test this, researchers launched a microprobe swarm from L2 orbit to monitor the coordinates continuously for 3 years. No second event occurred. However, during a 6-hour observation window in mid-2043, a polarization anomaly was recorded, an asymmetrical distortion in the electric field vector of starlight, localized to a point source. The anomaly rotated slightly over time, as though the light was passing through, or reflecting off, a moving lattice. The region has since been added to long-term monitoring protocols. Though the object has never reappeared, its existence is preserved in the light curves, carefully archived, simulated, and cross-compared. The lensing profile remains unique among thousands of recorded events. It suggests an object not only invisible, but architected to be so. Not an absence of light, but a design to bend light without leaving signature. A silence written not in radio or heat, but in curvature. If it was accidental, it was our one glimpse of something watching from the shadows. If it was deliberate, then someone somewhere allowed us to see. Once. When considering artificiality in the cosmos, one often looks for excess, bright energy bursts, massive structures, sudden changes. But the opposite can be just as telling. In the heat maps of dying stars, white dwarfs slowly radiating away their residual energy over billions of years, a handful of objects emit less than expected. Not slightly less, radically so. These are not simply cooler stars, they are dimmer than their theoretical thermal output by margins that exceed even generous error bars. The anomaly was first observed in a cluster within the Large Magellanic Cloud, where 8 white dwarfs showed suppressed infrared emissions across multiple instruments and epochs. Follow-up surveys with the infraspectral mapping network confirmed the suppression. The stars weren't absorbing less, they were emitting less, as though something was intercepting and managing their radiation. This raises an extraordinary possibility that these white dwarfs are enclosed or partially enclosed in heat-managing systems. Not total Dyson spheres, those would be vastly inefficient at this evolutionary stage, but rather compact, possibly partial shells designed not to capture power, but to regulate dissipation, a kind of long-term containment field. The reason for this would not be energy acquisition. A white dwarf's output is negligible for energy-hungry civilizations. Instead, containment may serve other purposes: thermal masking, data storage, or even memorial preservation. A civilization may choose to preserve the final light of a parent star, capturing its radiation, not to use it, but to keep it from fading, like placing a dying flame under glass. Simulations of these structures, coined thermal shrouds, suggest that even partial enclosures could alter the observed emission curves to match what's been detected. By using nano-engineered surfaces or plasma fields to scatter or redirect energy at wavelengths outside our detection range, the stars would appear dimmer while remaining thermally active. Alternative explanations have been proposed, including dust shrouds or dense planetary debris, but the uniformity of the effect across white dwarfs of different mass and origin makes this unlikely. Dust does not persist uniformly over such vast timescales. It dissipates. It reprocesses light in ways that do not match the observed profiles. Moreover, the white dwarfs in question show peculiar orbital relationships. Several belong to binary or trinary systems where the companion stars show no suppression, implying a localized constructed effect. In one case, the white dwarf's suppressed emissions were observed to fluctuate slightly on a periodic cycle, suggesting either rotation of the shroud or controlled modulation. No known natural process accounts for such a pattern. It appears neither random nor chaotic. It resembles a managed system, a thermostat perhaps, or a gate. We may be witnessing stellar objects in a kind of cosmic hospice, shielded, regulated, remembered. The civilizations that built such enclosures may be long gone, or they may remain, still watching the slow flicker of their ancient suns, waiting for the final ember to fade in a way of their choosing. In the icy outer regions of the solar system, dwarf planets exhibit a wide range of gravitational behaviors, some well-modeled, others anomalous. Among the most curious are localized gravity inversions, regions where test masses aboard flyby missions experienced measurable deviations from expected acceleration profiles, despite no corresponding change in visible terrain or mass density. These were not mission-threatening events. The deviations were tiny, micro-Gs at most, but consistently reproducible. They occurred in narrow corridors, often near ridgelines or basin rims, where gravitational vectors twisted in subtly non-Newtonian ways. One example, recorded during the Nereus 7 mission in 2038, involved a corridor along the equatorial ridge of Haumea. As the probe passed over a series of aligned troughs, its onboard accelerometers registered an upward vector component, an anti-gravitational nudge that could not be accounted for by terrain, ice composition, or solar tidal influence. These gravity inversions lasted seconds, yet they were precise, appearing at the same latitude and altitude on each pass. When reanalyzed, the regions correlated with weak magnetic anomalies as well as faint microwave reflections, suggesting buried structures or subsurface material density gradients inconsistent with natural ice formation. The leading theory posits that these areas may harbor hollow spaces, subsurface voids where mass has been displaced or restructured, but the patterning is too regular. The troughs align with orbital vectors, spaced evenly along arc segments matching fifth-order harmonics of the planet's rotational period. This implies a design principle, geometric, orbital, intentional. If these structures were created, they may serve as stabilizers, gravitational deflectors, or even inertial buffers, managing local gravity for navigation or energy storage. Alternatively, they may be remnants, the ghost lattice of once active systems now collapsed into the crust, their functions dormant, but their geometry persistent. No active field has been detected. The gravity anomalies behave like echoes, residual effects from long-dead systems, yet their persistence across billions of years suggests engineering not only vast in scope, but durable in concept. Future missions plan to drop microgravimeter pods across these zones, small self-powered beacons capable of mapping gravity fields at meter-scale resolution. If deployed successfully, they may reveal the full three-dimensional architecture of these inversions. Until then, the ridges hold their silence. They tilt gravity in gentle defiance of expectation. They tug at probes with unseen hands. A reminder, perhaps, that the laws of nature are not always broken, only rewritten by those who once knew how. Gravitational lensing has become one of astronomy's most powerful tools. By measuring how massive objects bend the light of more distant stars and galaxies, scientists can infer the presence of otherwise invisible phenomena, dark matter filaments, rogue planets, even isolated black holes. But in recent years, a handful of lensing events have emerged that defy gravitational logic. These are not distortions caused by mass, but apparent lensing without an adequate source, events in which light bends, but no measurable object occupies the foreground space. Such events are known as unexplained lensing events with no mass source, ULE-NMS for short. The most notable occurred in 2042 during a deep field survey targeting galaxy cluster LDN 1206, an extremely distant quasar over 9 billion light-years away, suddenly brightened and split into twin images for a span of 3.7 hours. The lensing profile was textbook perfect, a twin image formation with time delay, brightness amplification, and symmetric deformation, all the hallmarks of gravitational lensing. Yet when researchers mapped the foreground, they found nothing. No galaxy, no halo, no dark matter concentration. Even when the field was scanned across multiple spectra, radio, X-ray, infrared, there was no source of mass large enough to create the lensing effect. This absence was confirmed across 6 major observatories, including the James Webb Space Telescope, which resolved the region to arcsecond precision, the light bent. But nothing was there to bend it. Some proposed a rogue planet or black hole passed through the line of sight. But for an object to produce such a strong lensing event, it would need to possess many times the mass of Jupiter and be perfectly aligned, yet leave no other observational trace, no motion, no heat, no radiation, and crucially, no residual effect on the background field once the event concluded. Other researchers suggested a wormhole or transient mass fluctuation, a localized space-time distortion with no permanent presence. this remains within the realm of speculative physics. If true, it would represent a fundamentally different category of phenomenon, something that manipulates gravitational curvature without traditional mass. A minority of theorists posited that the lensing effect was not caused by mass at all, but by structure, an engineered gravitational refractor. That is, a device or construct placed in interstellar space capable of altering the path of light, not through its mass, but through manipulation of space-time geometry. The analogy would be to a magnifying lens made not of glass, but of gravitational fields themselves, assembled and calibrated with precision. This theory remains unproven. But simulations using distributed mass nodes, such as evenly spaced microsingularities or orbiting matter rings, have shown that artificial lensing is theoretically possible. Such systems could bend light to create temporary observation points, energy convergence zones, or even stealth fields. If such a lens exists, it may be mobile, perhaps even autonomous. It could pass through the galaxy, occasionally creating distortions detectable only when aligned with distant light sources. In this view, the lensing event was not an accident, but part of a function, a scan, a relay, a calibration. To test this idea, an international consortium launched the Ghostline Initiative, a network of high-cadence sky monitors focused on detecting similar short-lived lensing events. Over the following 18 months, 3 more ULE-NMS cases were logged, each lasting under 4 hours, each exhibiting perfect lensing symmetry, and each vanishing into empty sky. No common coordinates have emerged, no repeating schedule, just moments of warping, brief interruptions in the otherwise orderly path of light across space. They leave no debris, no echo, just questions. The Moon, Earth's only natural satellite, is often considered a known quantity. Every ridge, crater, and mare has been charted with exquisite detail. Yet even in its familiar face, there remain puzzles that resist explanation, one of the most enduring being the Moon's artificial thermal emissions at night. The anomaly was first recorded in the early 2000s when infrared imaging revealed that certain regions on the Moon retained heat long after local sunset. This residual warmth was not evenly distributed. Instead, it formed narrow bands, rectangular patches, and, most oddly, circular isothermal zones that corresponded to no known geological features. Initially, the cause was attributed to differing material compositions. Denser basaltic areas such as Mare Imbrium and Oceanus Procellarum were known to retain heat more effectively. However, some of the warm regions occurred in highland areas composed of anorthosite, a material with much lower thermal inertia. In 2029, data from the Lunar Reconnaissance Orbiter's Diviner radiometer revealed that certain regions glowed in the mid-infrared for hours longer than their surroundings, with temperature differentials up to 17 degrees Kelvin. The pattern repeated across lunar cycles and seasons, ruling out transient effects. More curiously, the shape and layout of the warm zones suggested a non-random arrangement. Some appeared in linear clusters, spaced evenly apart. Others formed concentric patterns inconsistent with impact ejecta or volcanic activity. When radar imaging was applied to these areas, unusual subsurface reflections emerged, weak yet regular. Beneath the regolith, about 2 to 5 meters deep, were layered structures with flat horizontal profiles and sharply defined edges. Some speculated these to be the remnants of buried platforms or ancient structures now covered by dust and time. A handful of scientists proposed a different hypothesis, that these thermal zones might not be natural at all, but residues, energy left behind by inactive systems designed to manage temperature. These could have been radiative pads, life support enclosures or containment areas that, long after their use, still influenced heat retention in the lunar crust. Skeptics argued that micrometeorite bombardment and solar wind erosion would have obliterated such structures over the Moon's long geologic history. But proponents countered that a well-designed system could bury itself intentionally, protected from exposure, or might even be self-regulating to some extent, triggering minor phase transitions in local materials to stabilize thermal output. Some suggested an even more intriguing function, that the warmth is not a residual effect, but a signal. That certain frequencies of infrared light are modulated through the heating and cooling cycles of buried components, sending a message detectable only through extended thermal monitoring. To test this, an experiment was mounted using Earth-based infrared telescopes aligned with known thermal zones. For over 14 months, researchers tracked their temperature curves during lunar night. Small modulations on the order of millikelvin were recorded. At first thought to be random, they later appeared in regular sequences, 5 peaks, then 3, then 2, repeating every lunar month. The sample size remains too small for statistical certainty, but the consistency raises a possibility that cannot be dismissed, that these thermal patterns may not be entirely passive. That someone or something engineered them to persist, perhaps for communication, perhaps for memory, or perhaps simply to mark a place that was once significant. Among the thousands of exoplanets catalogued to date, a handful exhibit a strange and rare phenomenon, oscillating reflectivity. These are not minor fluctuations due to cloud cover or rotation. These are large periodic shifts in the planet's brightness, often in wavelengths, where no known atmospheric or surface process should produce such variations. One of the most studied examples is K2 131b, a planet locked so close to its host star that its surface is believed to be partially molten. Yet, despite this extreme environment, it shows periodic dips and rises in reflectivity, particularly in near-infrared bands, every 19.7 Earth days. The prevailing theory is that large-scale surface changes, such as silicate rain or lava ocean currents, are responsible. However, similar fluctuations have now been observed on cooler, more temperate exoplanets, such as Gliese 67cc and TOI 849b, where such dynamics should not exist. What's most striking is the nature of the reflectivity curve. In some cases, it forms square waves rather than smooth sinusoidal patterns. This kind of transition, rapid increase, sustained plateau, abrupt drop, is characteristic not of natural processes, but of switches, of systems turning on and off. One explanation is technological albedo manipulation, that is, the use of vast structures or systems, perhaps orbital mirrors or ground-based reflectors, that modulate the amount of light the planet reflects. The purpose could range from thermal regulation to signaling. Or it could be a byproduct, an emergent effect of industrial-scale activity on the planet's surface. This idea gained traction when researchers modeled what Earth's albedo would look like from afar, assuming widespread energy farming. If vast solar farms tracked the sun and periodically folded or changed orientation, the result would be precisely the kind of reflectivity oscillations now observed elsewhere. The data, while incomplete, suggest intentionality. The changes occur at regular intervals, and they revert with high fidelity. No storms, no chaotic deviation, just a cycle, steady and repeating. Skeptics argue that we may be observing rare natural resonances, perhaps crystalline deposition cycles in atmospheres we barely understand. But the similarity across different planets, orbiting different types of stars, makes such explanations increasingly strained. Efforts are underway to observe these planets across broader spectral bands. If other correlated modulations are found in radio, infrared, or thermal emissions, it would bolster the hypothesis of artificiality. For now, we watch these distant worlds flicker, not randomly, but with rhythm, like lights in the fog, blinking slowly, intentionally, as if seen perhaps from across a great dark sea. The observable universe is filled with rhythm, pulsars ticking like metronomes, planetary transits occurring with mechanical regularity, magnetic fields cycling across solar bodies. But beneath that rhythm lies another, deeper stratum of pattern, one that spans orders of magnitude longer than human history. In the background of cosmic observation, an event has emerged, repeating neutrino bursts from the same celestial coordinates, spaced not over seconds or days, but over decades. The first recorded burst occurred in 1979, captured serendipitously by the Kamiokande experiment in Japan. At the time, it was disregarded as a calibration artifact, an unusually energetic spike with no corresponding solar or supernova activity. The direction of arrival pointed toward a sparse sector of the sky near the constellation Cetus. The event was noted, catalogued, and forgotten. 40 years later, in 2019, the IceCube Neutrino Observatory recorded a nearly identical burst from the same region. Once again, no visual or electromagnetic phenomena were observed in correlation. The neutrino energy profile matched the earlier event with uncanny precision, right down to the distribution spread across energy bins and incident angles. A pattern began to emerge, one impossible to explain through known astrophysical processes. The third event arrived in 2059. This time, the signal was anticipated. By now, an international effort had formed to track and analyze the phenomenon. The repeat interval, just under 40 years, suggested a deliberate schedule. Unlike typical astrophysical bursts, which fade or evolve, this one remained constant in energy output and directional focus, as though emitted by a perfectly stable source. Theoretical models diverged. Some proposed that a distant neutron star, possibly in a highly elliptical orbit around a compact partner, might create periodic magnetic alignments strong enough to focus neutrino emission. But such a model would likely show other side effects: radio flares, gravitational lensing, or pulsar timing signatures. None were found. Others proposed a neutrino lighthouse, a rotating source with a narrow beam sweeping the galaxy on a vast time scale. If Earth crossed the beam once every few decades, it could explain the timing. But again, such a mechanism would require immense precision and a power source far beyond any natural engine known to physics. A more radical hypothesis began to circulate, that the bursts are messages. Neutrinos are ideal for this purpose. They pass through nearly all matter, are difficult to intercept, and do not scatter like photons. A neutrino-based messaging system could operate across the galaxy undetected, unless the recipient knows to look. But if these are messages, what do they say? So far, the bursts are not obviously encoded. Each lasts just under 4 seconds, with a sharp rise and exponential decay in energy over that span. The spectrum remains consistent across all three observed events, but some researchers argue that the encoding may lie not in amplitude, but in timing. That the spacing itself between the decades could be part of the message, a galactic timestamp, or a kind of address intended for civilizations capable of both detecting neutrinos and maintaining memory across generations. If so, the signal has done its job. Plans are underway to build a long-duration neutrino monitor in lunar orbit, protected from Earth's atmospheric interference. It will be dedicated to constant surveillance of the Cetus sector. The next burst is predicted to arrive in 2099, give or take a few days. But some believe there may be subharmonics, smaller bursts embedded within the longer cycle, yet too faint for current detectors to perceive. Whether natural or constructed, the phenomenon has forced scientists to consider a kind of communication alien not only in origin, but in cadence, slow, patient, beyond the tempo of human attention. Perhaps the senders do not care whether we understand the message now, or even in the century. They simply send, as they always have, a pulse in the dark, repeated on a scale measured not in heartbeats or seasons, but in civilizations. Deep within the atmosphere of exoplanet WASP 76b, a hot Jupiter with temperatures exceeding 2,000 degrees Celsius, something strange occurs. On its night side, iron rains from the sky. On the day side, temperatures are so high that molecules are torn apart, then recombine in the fierce winds that blow across the terminator line, the divide between eternal daylight and endless night. This planet, locked in tidal rotation, was once considered a purely hostile environment, unsuitable for any form of life, natural or otherwise. But in 2041, during a full spectrum scan using the Vesper array, researchers noted a spectral signature inconsistent with known atmospheric chemistry, a repeating absorption pattern at a wavelength of 3.72 microns, forming a regular pattern over the course of 31 planetary rotations. This was not the signal of iron, hydrogen, or silicon oxides. It was a sequence of dips in energy that suggested regular structured occlusion, almost as though panels or objects were transiting the terminator zone in a consistent orbit, periodically blocking thermal emissions at regular intervals. The scale was immense. Each dip lasted approximately 18 minutes, implying an object or array of objects hundreds of kilometers across. Attempts to model the light curve using natural clouds or temperature oscillations failed. Nothing could account for the sharp edges of the occlusions and their strict periodicity. Speculation intensified. Could these be energy collectors? Massive sail-like constructs designed to harvest thermal differentials at the boundary between day and night? Or were they something more abstract? Weather moderators, or even planetary-scale data collectors measuring the planet's hyperdynamic atmosphere. Several researchers proposed that these structures might not be orbiting at all, but instead suspended magnetically or gravitationally fixed along the terminator line. Given the extreme wind speeds on WASP 76b, any physical object would require an immense anchoring mechanism, possibly using planetary magnetic fields or exotic matter tethers. If the structures exist, they are not visible in reflected light. They absorb completely. Their albedo is functionally zero in all measured bands. This has led to the theory that they may be made of metamaterials, engineered substances capable of bending or canceling light, effectively cloaking themselves in optical wavelengths while remaining thermally active. More puzzling is their persistence. The pattern has remained unchanged across 4 Earth years of observation. No drift, no degradation, no detectable precession. This implies active station keeping, whether by artificial control or intrinsic balancing. Attempts to locate radio signals or other forms of directed emission from the system have failed. The planet remains dark in all communicative bands, but that may be by design. A civilization or a construct using WASP 76b's extremes might have no need to speak. Its structures may simply function quietly within the storm. Some propose that we are not seeing technology in the sense we understand it, but something else. A planetary scale sculpture, an experiment in thermodynamics, or a kind of hypermachine whose purpose lies beyond extraction or utility. a work of physics, not of engineering. Perhaps WASP 76b is not just a hot Jupiter. Perhaps it is a chamber, a crucible, or a stage. Whatever the truth, the shadows continue to move, perfectly timed, perfectly silent, a clock with no hands. A system with no signal, only the rhythm repeating over and over on a world where iron falls from the sky and light is folded like cloth. In the search for signs of life beyond Earth, scientists often focus on biosignatures, chemical markers like oxygen, methane, or water vapor. But increasingly, attention is turning toward technosignatures, evidence of advanced technology altering environments in ways distinguishable from natural processes. One such candidate may have been uncovered in the form of repeating radio echoes emanating from a stellar nursery in the Carina Sagittarius arm. The region, designated as Car-Sag Echo 9, is home to a vast molecular cloud complex undergoing high-rate star formation. Embedded deep within the dust is an energetic protostar system which emits standard outflows of plasma jets and infrared heat. But over the course of a multi-year observation campaign conducted by the Low-Frequency Resonance Array, researchers detected a strange phenomenon: rhythmic radio echoes, delayed repetitions of natural signals that should have dispersed in the interstellar medium. The signals were first dismissed as multipath interference caused by reflections off interstellar gas clumps. But the regularity of the echoes, separated by exactly 72.81 seconds, and their diminishing amplitude over a logarithmic curve, contradicted this explanation. Natural reflections would exhibit smearing and chaotic delay due to dispersion effects. These echoes were clean, sharply defined, and spectrally intact. More puzzling was that the echo pattern persisted even when the original signal was removed from the source. In one instance, a Type 3 solar flare-like radio pulse from a nearby protostar was mirrored before the original arrived. The echo led the pulse by a full delay interval, suggesting it was not a reflection at all, but a repeated pattern, independent of the original transmission. This led researchers to consider the possibility of signal mimicry. In such a model, a system within the stellar nursery may be replaying received cosmic signals on a delay, like a cosmic tape recorder operating on autopilot. Whether the source is natural or artificial remains debated, but several aspects point toward the latter. First, the location. The echoes originate from a fixed locus within the cloud, not diffusely throughout. Second, the timing. Delays are too precise to be the result of chaotic scattering. And third, the fidelity. The signal copies retain spectral harmonics too cleanly preserved for random dispersion. Speculative theories abound. One posits that we are witnessing the operation of a long-dormant observational mechanism, possibly a relay that passively records and rebroadcasts electromagnetic activity from its surroundings. Another suggests the echoes are a ping response system, a passive radar field established to detect motion or activity within the cloud. Every pulse it receives is answered by a delayed return, allowing for the monitoring of interference patterns that could indicate ships, probes, or migrating stars. A more abstract possibility is that we are observing a kind of memorial mechanism, a device or process that replays once heard signals at regular intervals, perhaps for symbolic, navigational, or functional reasons. Such a system may have no intended audience. It may simply be doing what it was built to do, looping a slice of the universe's music until silence overtakes it. Attempts to map the exact location of the echo source have narrowed it to a dense gas node approximately 20 light-years across. However, this node has no internal light source and appears in optical surveys as a void. its radio emissions are the only sign of internal activity. No modulation, no language, no encoding, only the repetition of what was already heard. A kind of passive sentience or a mechanical memory caught in loop. Whether the echo is technology, artifact, or unknown natural behavior, it raises a profound possibility that not all technosignatures announce themselves with power. Some may whisper, some may only repeat, and some may lie buried in the births of stars, playing out patterns written by unknown hands in a dialect of silence and delay. Among all known stars with planetary systems, TRAPPIST-1 has drawn perhaps the greatest attention in the search for life. 7 Earth-sized worlds, 3 of which orbit within the habitable zone, circle this ultra-cool red dwarf just 39 light-years away. With synchronized orbits and frequent transits, TRAPPIST-1 offers unparalleled opportunities for study. Yet, despite dozens of observation campaigns, the system has remained frustratingly opaque. One reason, persistent anomalies in the timing of its planetary transits, small rhythmic deviations from predicted orbital paths, as though the planets are subtly influenced by external forces not accounted for in models. Initially, these variations were attributed to planetary gravitational interactions, but as the data accumulated, a pattern emerged. The deviations were not random, nor were they consistent with only planetary resonance. Instead, they oscillated in a high-order harmonic, matching the cycles of the host star's magnetic activity, but leading it, arriving ahead of each new flare by consistent margins. This suggested an influence beyond mere gravity. One hypothesis proposes the presence of magnetically coupled structures, objects orbiting the star at higher altitudes, transferring torque or current to the planets via magnetic fields. Such constructs, if real, could alter orbital velocities without physical contact, adjusting planetary motion in ways that mimic gravitational interference. The theory, nicknamed orbital shepherding, implies the existence of an engineered system, a framework designed to maintain planetary stability over deep time, or to synchronize orbital phases for unknown purposes. It may be a defensive mechanism, a climate stabilizer, or even an ancient relic no longer monitored but still functional. Further evidence comes from the light curve of TRAPPIST-1e, which exhibits ultrafine modulation not seen in the other planets. Every 6.2 days, its transit depth varies by less than 0.1%, in a waveform that precisely matches a repeating Fibonacci sequence over 10 cycles. This degree of precision in transit variation is unprecedented and difficult to explain through atmospheric weather or surface albedo alone. Some speculate this modulation could be the product of surface-based structures, vast arrays or signal devices affecting the planet's apparent brightness during transit. Others believe it may be an effect of orbiting platforms, possibly reflectors, emitters, or monitoring stations aligned with specific transit geometries. Spectroscopic data has revealed nothing overtly artificial, but the absence of chaos, the regularity of the patterns, and the resonance with stellar activity cycles all point toward long-duration equilibrium management, something built not to be seen, but to last. In this interpretation, the TRAPPIST system may not just be a cradle for life, it may be a machine. A construct in which planets are tuned, like gears, to interlock and resonate not for efficiency, but for purpose. Whether that purpose includes communication, preservation, or seclusion is unknown, but the harmony of the system, its strange, engineered calm, remains. A puzzle of precision, a clock with 7 hands keeping time for reasons we have only begun to guess. Far beyond Pluto, where sunlight is little more than a cold memory, The Kuiper belt blurs into the scattered disk, a population of icy bodies on erratic orbits. Some swing inward every few thousand years. Others arc silently through darkness, nearly perpendicular to the solar plane. It is here, in the region once considered gravitationally empty, that anomalies in trajectory have been quietly accumulating. In the late 2030s, long-term tracking of trans-Neptunian objects, TNOs, revealed an unsettling pattern. Tell me, a subset of bodies, including 2007 TG422, 2015 TH367, and 2028 PV43, exhibited subtle but consistent perturbations in their paths, deflections that could not be accounted for by gravitational modeling alone. The deviations were minute, fractions of a degree over decades, but all aligned toward a common vector in space, located in the direction of the constellation Volans. Initially, this clustering was folded into the search for Planet 9, a hypothetical massive body thought to shepherd the outer solar system's architecture. But as more data accrued, the perturbations resisted the models. They lacked the chaotic dispersion expected from a large, unseen mass. Instead, the TNOs appeared to course correct, as though nudged not by gravity, but by proximity to something localized and precise. This led to a controversial proposal that there exists a field, non-gravitational, non-electromagnetic, embedded within the outer heliosphere, capable of interacting with small masses through unknown mechanisms, dubbed the Volans vector. This theoretical region is thought to extend over a narrow corridor of space and may exert influence only under certain conditions, perhaps dependent on orbital velocity, orientation, or material composition. Supporting this idea is the anomalous behavior of two artificial probes. The first, Voyager 3, launched in 2035 to follow a hyperbolic escape trajectory past Neptune, experienced a 2% velocity increase near the projected intersection with the Volans vector. The change was brief, uncorrelated with solar wind, and not attributable to onboard thrust. The second probe, Solstice Pathfinder, recorded a high-frequency vibration in its magnetic coils as it passed the same region, despite measuring no magnetic field. If these readings are valid, then the Volans vector may represent more than a passive field. It could be a boundary or a gate, a threshold engineered to monitor or restrict the movement of objects entering or exiting the solar system at specific trajectories. Not a wall, but a filter. Some researchers have drawn comparisons to theoretical transit corridors proposed in galactic navigation models, paths of least resistance through gravitational domains, perhaps marked or maintained by advanced civilizations for the purpose of safe interstellar passage. If the Volans vector is one such corridor, Earth and its system may be a node on a greater route map, invisible to us, but ancient in design. The implications are vast. If our outer system is structured, even subtly, by unknown intent, then what appears random may be deeply constrained. The scattered disk may not be scattered at all. It may be organized, shaped, managed. The next generation of probes, including the Sentinel Drift Array, will deploy passive sensor buoys along intersecting paths through the region, searching for phase changes, particle fluctuations, or geometric anomalies. They will drift for decades, perhaps longer. Silent witnesses to whatever lies at the edge. For now, we peer outward, tracing the bends in cold trajectories. We watch the sky tilt slightly, inexplicably, toward a single point in the dark. And we wonder, are we being allowed to pass, or being kept in? Within the dark skies of the early 21st century, astronomers made a puzzling discovery, a star that disappeared. Designated TYC 8241 26521, this main sequence star was stable, luminous, and easily cataloged. But over the course of a decade, it faded rapidly, its light curve dropping by over 97%, before vanishing entirely from the optical spectrum. Initial theories suggested obscuration by dust clouds or debris disks, but no corresponding infrared excess was detected. The star simply dimmed. Further complicating the matter, the disappearance was not absolute. Deep field observations showed occasional flickers, irregular and brief, suggesting the star still existed but had been eclipsed or hidden by an unknown mechanism. This was not the only case. 3 more stars in widely separated regions of the sky were later found to exhibit similar behavior: sudden and unexplained dimming, followed by prolonged darkness. These objects came to be known as vanishing stars, and they defy all known stellar evolution models. The leading speculative hypothesis is that these stars are being enclosed, not destroyed, by megastructures such as Dyson swarms or cloaking arrays. Such structures would obscure visible light while either redirecting or storing the star's energy output. Unlike classical Dyson spheres, which would re-radiate energy in the infrared, these hypothesized constructs appear to suppress emission across multiple wavelengths. That implies not just energy collection, but energy regulation, or total energy sequestering. This level of control would be indicative of an extremely advanced technological civilization, Type 2 or beyond, on the Kardashev scale. But the question remains, why hide a star? Some suggest defensive camouflage, shielding the star from potential detection. Others propose that these systems are entering a form of engineered hibernation, preserving their energy output for future use. Still others entertain the idea that the stars themselves are being modified, that they are components in a much larger machine. A more radical theory posits that the disappearing stars are not being enclosed, but being removed, shifted out of observable space-time via manipulation of gravitational fields or quantum tunneling. In this view, the stars are not gone, but translated, taken offline from our visible universe for reasons beyond our current comprehension. Attempts to track gravitational lensing events around these coordinates have yielded ambiguous results. Some faint distortions, barely above the noise floor, suggest the presence of mass, but without accompanying light or heat, the signals remain inconclusive. Whether these stars have been hidden, transformed, or displaced, their vanishing adds a new dimension to the search for technosignatures. Not all advanced civilizations may choose to shine. Some may instead choose to disappear, to veil themselves not out of weakness, but out of purpose. The light is gone. The coordinates remain. And across the dark sky we mark the absences not as accidents, but as messages. Each vanished star a silence, each silence a sign. The architecture of the universe is defined by structures so vast they stretch beyond the mind's immediate grasp. Superclusters of galaxies, filaments of dark matter, voids where galaxies are few and far between. But embedded within this grand architecture are patterns that defy randomness. One such anomaly was uncovered during the Deep Void Mapping Initiative, which sought to chart the largest known empty spaces in the cosmos. In the process of scanning the Eridanus supervoid, researchers discovered a repeating pattern of galaxy alignment stretching over 1 billion light years. This galactic braid, as it came to be called, consists of spiral galaxies whose angular momentum vectors are not randomly distributed, as would be expected from standard cosmological models, but aligned in long, sinuous filaments curving through intergalactic space. The statistical odds of such alignment occurring naturally are infinitesimal. Galaxies form independently, subject to local gravitational fields and chaotic merger histories. Yet in this braid, spanning over 1,800 galaxies, spin axes point in coherent directions, following a helical trajectory across a region that should be entirely disconnected. The effect was confirmed by radiopolarization studies and redshift-corrected angular analysis. These galaxies are not near each other in three-dimensional space. They are arranged like pearls on a twisted strand, separated by hundreds of millions of light years, yet spinning in unison. Cosmologists attempted to explain the alignment through tidal torque theory, which describes how angular momentum arises from the uneven distribution of matter in the early universe. But even under the most favorable simulations, the coherence and scale of the braid could not be reproduced. This led to an unprecedented proposal that the galaxies had been guided into position, not by dark matter, but by influence, that long ago something acted upon them. Not to alter their locations, but their spin. Galactic spin requires tremendous torque to manipulate. No known natural force acting after formation could exert such control without shredding the galaxies apart. The alignment, then, must have occurred during the galaxy's formation, or perhaps even earlier, in the pre-galactic density field itself. If engineered, this would imply intervention at the scale of cosmic inflation, suggesting that the imprint of intelligent activity may exist not only on planetary or stellar scales, but embedded into the very scaffolding of the universe. Some propose a subtler motive. The galactic braid may be a marker, a signpost designed to be seen only by those civilizations capable of mapping millions of galaxies in detail. Its message would be spatial, not linguistic, a coordinate, a direction. Others suggest it may be functional. The braid may facilitate long-range gravitational lensing corridors or form a basis for hyperspatial resonance communication. Its aligned angular momenta generating a rhythmic gravitational pulse across the fabric of space-time, perhaps acting as a cosmic repeater system. To test the idea, instruments like the Gravem EchoNet have been deployed to measure low-frequency gravitational wave fluctuations across the braid's trajectory. Early data hints at subtle modulations, barely detectable oscillations in the femtohertz range. Though far from conclusive, the waves are coherent and periodically phased. This would be the first time gravitational architecture has been considered not merely the background of cosmic activity, but an artifact in itself. Not the stage, but the script. Whether natural or not, the braid remains. Twisting silently across the void, connecting galaxies not with matter, but with motion. A helix of spin, impossibly coordinated, a curve too perfect to dismiss, a signature perhaps, or an invitation. At the outermost edge of human observation lies the cosmic microwave background, an ancient afterglow from the birth of the universe. It is the oldest light we can see, stretching uniformly across the sky, marbled with tiny temperature fluctuations. These fluctuations have served as a blueprint for cosmological models, allowing us to measure the age, shape, and fate of the cosmos. But in 2045, a reanalysis of data from multiple CMB observatories revealed a perturbation, a long-forgotten anomaly reinterpreted in new light. First detected in the early 2000s and dubbed the cold spot, this unusually large and cool region of the CMB spans roughly 5 degrees of sky and appears to deviate from expected statistical norms. Though once attributed to chance or to the presence of an immense supervoid, new polarization and phase coherence measurements suggest something stranger, an embedded signal. When the cold spot's temperature data is converted into a frequency domain, transforming temperature variance into waveform amplitude and overlaid with hyperdimensional Fourier analysis, a pattern emerges, a complex harmonic sequence nested within the noise. Not just random fluctuations, but a structured cascade of peaks and troughs following a logarithmic rhythm. The harmonic spacing corresponds not to known physical constants, but to ratios consistent with information theory, compression ratios, bit intervals, and error-correcting codes. It's as if the cold spot isn't just an absence of energy, but a storage medium. Researchers at the Max Planck Institute, using quantum-enhanced deconvolution techniques, extracted what appears to be a packet of highly compressed data. Not enough to constitute a message in the traditional sense, but too structured to be entropy. The encoding is non-repeating yet deterministic. It may be a fingerprint or a flag. One interpretation suggests that this signal was imprinted during the last moments of inflation, encoded into the background radiation by an intelligence capable of manipulating the universe's boundary conditions. In this view, the cold spot is a cosmic watermark, a calling card placed at the beginning of time. This reframes the entire search for alien intelligence. We've been looking for signs in the present: radio waves, megastructures, planetary anomalies. But what if the first message was always in the past, written not on worlds, but on time itself? Efforts are underway to refine the signal extraction. Some hope to reconstruct a minimal language, a foundational syntax that could be universally understood. Others are skeptical, suggesting that we may be misinterpreting randomness as design. But even the skeptics admit the cold spot is different. Too large, too coherent, too structured to ignore. Perhaps it is a map or a seed, or simply the equivalent of a cosmic "we were here." If the universe was written into existence, this may be the signature at the bottom of the script. In the early days of radio astronomy, one of the first phenomena to capture researchers' attention was fast radio bursts, brief, intense pulses of radio waves arriving from deep space. Initially thought to be rare, they have since been cataloged by the thousands. Most are singular, unpredictable events, but a small subset repeat. And among those, an even rarer few exhibit strict periodicity, arriving not randomly, but on a fixed schedule. One such object, designated FRB 19052b, was detected pulsing at seemingly irregular intervals until, after long-term observation, a 157-day modulation cycle was discovered. But in 2044, a new repeating FRB entered the record, designated FRB 440221a, with characteristics unlike any other. Unlike typical fast radio bursts, FRB 44021a consists not of a single spike, but a triple pulse cluster spaced over exactly 3.15 seconds, each subpulse timed with millisecond precision. The full cluster lasts only 8 milliseconds, but repeats every 3/14 days, matching the digits of pi to astonishing precision. Coincidence was the first assumption, but then a second burst arrived at precisely twice the interval, then another at half. Each conformed to ratios of pi and its derivatives, a mathematical motif coded into timing rather than frequency or amplitude. What's more, the source direction, located in a faint inactive elliptical galaxy 1.9 billion light-years away, has shown no other energetic activity. No X-rays, no supernova remnants, no pulsar emissions, just the bursts, clean, fast, and resolutely timed. The FRB's energy profile follows a Gaussian envelope with such uniformity that random natural phenomena have been all but ruled out. Statistical analysis places the probability of its timing and structure emerging from chance at less than 10^18. A new term entered the scientific lexicon: mathematical technosignature, a signal whose content is pure abstraction, expressing relationships between irrational numbers, ratios, and constants universal to all forms of intelligence. A way of communicating without language, context, or biology. This theory was tested further when researchers began running the timing sequences through spectral transforms. In Fourier space, the bursts form self-similar harmonics with nested interference patterns. When converted to audio and slowed, the waveform produces a fractal tone, a recursive modulation whose repetition mirrors the structure of musical harmonics and digital signal encoding. Is this an announcement, a test signal, a beacon, or an artifact from a civilization that long ago mastered cosmic mathematics and left behind a calling card designed to persist through entropy? The energy levels involved are immense, yet they show no sign of decay across the nearly 2 decades they've been monitored. No drift in frequency, no slippage in timing. They're perfect, more perfect than any terrestrial system could maintain without active synchronization. Some propose that FRB 440221A is an automated system, a long-lived beacon designed to run until the end of the baryonic era, powered by decay, dark matter harvesting, or zero-point extraction. Others posit that it may not be a message to us at all, but rather an internal system communication between machines or civilizations across intergalactic distances. If so, we are intercepting only the residue, a third party listening to a network that does not include us. And yet, the signal is there, regular, mathematically fluent, like a voice humming to itself in the void, unaware or unconcerned with who listens. In the Martian southern hemisphere lies a crater so ancient it is barely discernible from its surroundings. Hellas Planitia, over 2,300 kilometers wide and 7 kilometers deep, it is one of the largest known impact basins in the solar system. For decades, it was treated as a purely geological feature, a record of planetary trauma billions of years old. But during a series of low-altitude synthetic aperture radar passes conducted by the Ares Reconnaissance Array, a subtle but highly unusual pattern emerged beneath the sediment. At roughly 1.5 kilometers below the surface of the basin's central plain, a set of regularly spaced vertical anomalies were detected, pillars of high-density material extending upward from the bedrock in a precise hexagonal grid. There are 144 of them. Each measures approximately 35 meters in diameter, extending as tall as 800 meters, and separated from each other by exactly 1.618 kilometers, the golden ratio in planetary scale. These structures cannot be explained by volcanic activity. They are not pipes, dikes, or mantle plumes. The regular spacing, identical dimensions, and geometric spacing make any natural process not merely improbable, but functionally impossible. Core samples from previous landers near the basin found microcrystalline metallic inclusions, specifically tungsten and rare earth traces, not typically associated with Mars's crustal composition. These materials are known for their resistance to heat and structural deformation. The suggestion is clear. These pillars are not natural intrusions. They are remnants, anchors, foundations. But for what? One theory posits that the pillars once supported a dome, either physical or energetic, that spanned a portion of the Hellas Basin. Such a structure could have provided atmosphere retention, thermal regulation, or shielding. If Mars once harbored a sealed environment in this region, it would have required significant support, especially in such a massive depression. Another theory is more abstract. The pillars are a form of planetary scale computing substrate. Their spacing, composition, and layout could function as part of a geological scale information system, a primitive or post-primitive attempt at storing, processing, or modulating data through environmental resonance. Not silicon circuits, but mineralogic gates, slow, resilient, and massively distributed. Still others suggest a symbolic purpose, that the grid is not meant for function, but for memory, a planetary-scale monument or signal meant to persist long after the builders are gone. The Hellas grid, as it is now known, has become a prime target for subsurface drone deployment. The next generation of landers will include sonic imaging arrays and plasma drilling tools designed to extract core samples directly from the pillars. But until then, the structures remain buried, hidden beneath 1 million years of Martian dust, waiting quietly beneath the planet's deepest wound. Not visible, not vocal, but undeniably there. Of all the moons in the solar system, few are as enigmatic as Enceladus, a small icy satellite of Saturn. Its surface glows with a high albedo, reflecting nearly all the sunlight that touches it. Beneath its frozen crust lies a vast subsurface ocean, kept liquid by tidal flexing from Saturn's gravity. Plumes of water erupt from its southern pole, venting material hundreds of kilometers into space. These geysers have made Enceladus a prime candidate in the search for extraterrestrial life. But what has recently emerged from that search goes far beyond microbial hope. During a series of high-resolution imaging passes in 2046 by the Argo 2 orbiter, attention turned to the spatial pattern of the geyser vents themselves. The major fissures, known as the tiger stripes, are not random. They are spaced in perfect intervals with angular displacements of exactly 45, 90, and 135 degrees relative to Enceladus's spin axis. The eruption intervals, too, show a strange rhythm, plume cycle not solely with orbital position, but with periodicities that match Saturn's rotational harmonics. Even more unusual is what lies within the plumes. In addition to water, salts, and organic compounds, the Argo 2 onboard mass spectrometer detected a recurring, highly ordered sequence of complex polycyclic aromatic hydrocarbons, molecules typically associated with combustion or synthetic manufacturing. These sequences are not only repetitive, but statistically improbable to form by natural processes. The same molecular chain, C6H24O6 and Benmos, was detected in 31 separate eruptions across a 3-year window. This exact compound has no known biological or geological source. On Earth, it only appears in advanced chemical engineering environments. Further compounding the mystery is the isotope ratio of certain elements in the plume material. Oxygen-18 and deuterium levels show cyclical deviations, almost as if a process is selectively fractionating isotopes within the subsurface ocean before ejection. Natural processes can cause isotope variation, but not in a rhythmic pattern synchronized with the Moon's orbit. One bold theory proposes that the plumes are not mere geological events, but components of a controlled release system, that Enceladus may harbor internal structures, biological or artificial, that maintain environmental regulation through venting. The geysers, then, are not accidents. They are maintenance. Others suggest that the vent chemistry is a form of signaling, that the plume content has been altered to embed information, not in radio or light, but in chemistry. In this theory, the molecules are a form of slow transmission, coded in sequences only readable by civilizations capable of in situ molecular spectroscopy, a kind of message written not in photons, but in atoms. Attempts to decode this possibility are ongoing. Researchers at the European Astrobiological Institute are experimenting with the idea of chemolinguistics, using the sequence and structure of compounds as the basis for an abstract syntax. Early results show patterns in bond symmetry and charge distributions that resemble encoding protocols, checksum-like structures, nested parity elements, and mirrored substructures. If Enceladus is transmitting, it is doing so in a dialect we have never encountered. Even more compelling is a heat anomaly found beneath the South Pole. Thermal imaging revealed a circular region of elevated temperature beneath the crust, about 6 kilometers below the surface. Its shape is not irregular like magma pools or heat plumes. It is concentric with a cool center and warm perimeter, a thermal ring precisely 12 kilometers in diameter. No natural convection model can account for such a profile. Could it be a reactor, a biosphere dome, a protective vault? The questions multiply. Plans are now forming for the Enceladus Descent Probe, a mission that would land on the ice near a major vent, melt through the crust using a heated probe, and deploy an autonomous swimmer into the subsurface ocean. But it will take decades to reach the moon, and longer still to return data, if it ever returns. Meanwhile, the geysers continue. They fire not randomly, but in cycles, their chemical voice growing more insistent with each pass. Whether by design or by chance, Enceladus now stands as one of the most likely candidates for non-human agency in the solar system. And yet, it remains silent, at least in the forms we understand. Perhaps the silence is the message. In the records of early SETI history, one incident remains singular, the WOW signal detected in 1977 by Ohio State University's Big Ear radio telescope. A 72-second narrowband burst. It came from no known satellite or celestial source. It was never repeated. It was never explained. But in 2047, nearly 70 years later, a new signal arrived. Nearly identical in structure, same frequency range, same duration. But this time, it repeated. The signal was captured by the Far Edge Deep Field Array during a blind scan of the Hercules constellation. It began at 14.20, 456 MHz, the hydrogen line, favored for interstellar communication, and lasted precisely 72 seconds. Then, after 1420 plus 456 MHz, it repeated, and again. A triple transmission. The signal bore striking similarities to the original WOW signal: frequency drift, signal strength curve, narrowband structure, but now with repetitions spaced 144 seconds apart. And in the second burst, a modulation was detected, subtle amplitude changes forming a repeating binary sequence. 10-1-1-1-1-1-1-1-1. When converted into ASCII binary, the pattern resolves to non-printing characters. But when parsed through Unicode hexadecimal, it yields a repeating mathematical motif, 2PE. Not the values themselves, but the ratios between their decimal expansions. This is not data. It is identity. A fingerprint written in the most universal language, mathematics. Unlike other signals, this one faded not into silence, but into noise. After the third burst, a wide spectrum scattering occurred like a stone dropped in water. Harmonic ripples radiated outward across 3 meters of bandwidth, fading into background cosmic noise, as though something had turned off, not abruptly, but softly, elegantly. The transmission has not repeated since, but its precision, content, and symmetry have ignited a new wave of global SETI activity, not in search of sound, but in search of structure, spectral balance, prime-timed repetitions, the kinds of anomalies that don't shout, but whisper. If this signal came from the same source as the original WOW event, it implies a sender of exceptional patience, one willing to wait nearly a human lifetime before repeating a greeting. Or perhaps it never stopped. Perhaps we've simply lacked the tools, the perspective, the patterns to see the messages hiding in the cosmic static. The hello may have always been there. We just learned how to listen. In the realm of speculative astrophysics, some anomalies are too faint to study but too precise to ignore. One such case emerged from a 20-year accumulation of observational noise, a background hum discovered only by accident, buried within the rotational data of pulsar PSR B1931+24. Known for its unusual stop-start behavior, this pulsar turns on and off in a 35-day cycle, pulsing for about a week before falling silent. This alone is rare. But what was previously overlooked was what came during the silences. When the pulsar was off, a residual signal remained. Not in the radio band where its pulses normally scream across space, but in the low-frequency electromagnetic spectrum, just above the range of known cosmic background emissions. This residual hum pulsed as well, not at the same rate as the pulsar's regular emissions, but at a slower beat, one that appeared to encode modulation. Initially dismissed as magnetospheric echo or data bleed, the signal was revisited using interferometric filtering and deep noise subtraction algorithms. Once isolated, the pattern began to emerge. Over each off-cycle, the signal drifted in frequency slightly, matching over time the harmonic series of the A4 note on the human musical scale, 440 Hz and its octave multiples. This was not a signal anyone would have noticed directly. It was too quiet, too well hidden beneath the dominant emissions, but once extracted, it showed all the hallmarks of deliberate phase control, a waveform so stable that, had it been produced by Earth-based instruments, it would require atomic clock precision. Further inspection revealed subtle amplitude modulation within the waveform, forming a quasi-rhythmic pattern that repeated every 7.231 Earth days. The duration corresponds neither to any known stellar rotation nor gravitational lensing event, but it closely mirrors a fractional resonance found in the orbital period of Jupiter's moons. This incongruity led to an unsettling hypothesis, that the signal is artificial, not emitted by the pulsar itself, but injected into its magnetosphere from an external source. Pulsars have long been proposed as galactic navigation aids, stellar lighthouses, whose regularity makes them ideal reference points for spacecraft or deep-time positioning. But what if some have been modified? What if the precise, anomalous pulsars like PSR B1931+24 are not only natural clocks, but co-opted beacons carrying embedded timing pulses for those who know how to read them? In this view, the off phase is not a loss of signal, but a change of function. The star stops shouting and begins whispering. It pulses less for visibility and more for precision, delivering sync codes, positional keys, or even communication packets through the manipulation of deep field radiation. No direct message has been decoded. The waveform is too subtle, the encoding, if it exists, likely buried in phase shift minutiae or topological rotations. But the timing, the frequencies, and the harmonic structure all suggest something unnatural, something designed not to transmit power or content, but to maintain structure across time, across space. One researcher described it as the universe clearing its throat quietly in a forgotten key. Pulsar PSR B1931+24 remains under constant surveillance by a dozen global radio arrays, not for what it says, but for what its silence now implies. At the very boundary between galaxies lies the intergalactic medium, a tenuous, whisper-thin lattice of plasma and dust, nearly impossible to detect and rarely discussed. It is the ocean between the islands of stars, cold and dark and seemingly inert. But a recent study by the Null Horizon Network has begun to challenge that assumption. Using an array of high-sensitivity ultraviolet detectors, astronomers began mapping Lyman alpha emissions from distant hydrogen clouds in the voids between galaxies. While most emissions were chaotic and diffuse, consistent with known recombination processes, a few were not. A handful of emissions showed coherence, spatial regularity, rhythm. The brightest of these came from a point roughly 780 million light-years distant, in an area with no galaxies within a 10 million light-year radius. A true void. Yet from this emptiness emanated a narrow-band ultraviolet pulse, repeating every 13,278 seconds. The pulse profile was square-edged and perfectly symmetrical, a sign that the emission was gated, not natural. Even more striking, the pulses displayed redshift corrections inconsistent with a fixed source. The Doppler profile suggested minute accelerations, as if the emitter was slowly tumbling or intentionally scanning its beam across a segment of space. It was the pulse phase, however, that drew the greatest interest. Across 21 pulses, the waveform's zero crossing point, the moment where the electromagnetic wave crosses from positive to negative, advanced by a constant fraction of Planck time with each emission. This kind of consistency is not known to occur in nature. It implies a clock regulated at the quantum level. No natural process operates with this kind of symmetry in intergalactic space. The region is too sparse, too cold, too uneventful. And yet, here was a beacon, barely energetic, but impossibly precise. When extrapolated backward, the beacon's origin date suggested an initial activation point, approximately 12.8 billion years ago, before our galaxy had even completed its first rotation. If accurate, the emitter predates most known structures in the universe. Theories emerged in waves that this is a time capsule built by a pre-galactic intelligence, that it is a metronome, a synchronization pulse for civilizations evolving in different galaxies, spread too far to communicate, but aligned in chronology, that it is a signal not to be answered, but merely acknowledged, a heartbeat in the void to say, we reached here first. Its energy output is minimal. It cannot be a navigation aid. It does not deliver information, but its persistence, its refusal to deviate even after billions of years, suggests a purpose as foundational as any monument. Perhaps it is a test, a signal left to see who can detect not noise, but discipline, who can find order not in brightness, but in subtlety. If so, we have passed that test. And now, having found it, we must ask, what do we do with the knowledge that someone marked the emptiness between galaxies with a quantum-calibrated whisper? A final anomaly, among the most haunting, emerges not from space, but from time. In 2048, a consortium of physicists working on ultra-high-precision atomic clocks began a timekeeping experiment aboard the Kepleris station, a zero-gravity lab at the Earth-Moon L2 point. Their objective was to study minute variations in time dilation under stable conditions. But over a 73-day window, something unexpected occurred. The clocks began to drift, not from each other, but together, in perfect sync. Their frequencies shifted upward by 12 parts in 10^18, sustained for nearly 21 seconds before returning to baseline. This is not a normal deviation. No gravitational anomaly was recorded. No solar event occurred. No magnetic field fluctuation was measured. The shift was global to the station, affecting all clocks, even redundant systems sealed in isolated housings. It was as if time itself had surged slightly forward across a localized pocket of space. Worse still, when the data was time-stamped and cross-referenced with Earth-based atomic clocks, a slight desynchronization remained, on the order of 1.7 picoseconds. This may seem trivial, but in quantum systems, such a drift can destabilize cryptographic keys, destroy quantum coherence, or render GPS networks unstable. The effect was not repeated. No cause was identified. But in the aftermath, researchers discovered a curious side effect. During the time drift, one of the station's passive EM field sensors registered a burst of ultra-low frequency oscillation, far below human hearing, close to the Schumann resonance range. The waveform had 6 peaks. Their spacing, when converted to timestamp intervals, matched the Fibonacci sequence up to the 6th value, 1, 1, 2, 3, 5, 8. No known system aboard the station could have generated this signal. No external transmission was detected. It was as if something outside of known physics had nudged local time forward by a quantum breath and left behind a trace, not of matter, not of energy, but of intent. Among all the discoveries chronicled across the years, some defy categorization not because of what they show, but because of what they almost do. Such was the case with an observation made by the Asterion Deep Field Lens, a wide aperture array launched in 2042 to image gravitational shear in galaxy clusters. It was designed to map mass distributions invisible to the eye, dark matter filaments, microlensing distortions, background warping. But during a deep integration aimed toward the Able 3266 cluster, it captured something entirely unanticipated. The images revealed a structure, or the echo of one, not in optical light, but in gravitational lensing itself. Spread across approximately 50 million light-years, the lensing data showed consistent angular discontinuities. Light from background galaxies bent at precise angles, forming straight lines and corners in patterns nature does not produce. Not curved distortions from gravity wells, but polygons, hexagonal warps, triangular deviations, square planar shears. These shapes formed a grid overlay, detectable only when the gravitational fields were analyzed through angular deconvolution. At first, this was assumed to be a processing error, perhaps an aliasing artifact or software glitch. But when the observation was repeated from a different array angle, and again from a backup aperture months later, the pattern persisted. Independent teams confirmed it using separate datasets, including raw photon transit delays and redshift deformation overlays. This phenomenon, quickly dubbed the tessellation anomaly, did not move. It did not pulse. It did not radiate. But it did bend light in a manner consistent with engineered refractive mass, not a structure of matter, but a structure of space. A framework that manipulates space-time curvature not locally like a star or a black hole, but across enormous expanses, millions of light years. No visible mass accompanied the tessellation, no dust, no radio emission. It was purely a lensing phenomenon, a shadow geometry revealed by starlight bending along paths we never expected to be constructed. One hypothesis proposes that the anomaly is an ancient megastructure, perhaps one beyond material existence. A gravitational lattice designed not to emit or absorb, but to channel the passage of light and energy through vast volumes of space, not to obscure, but to frame. Such a construct would be incomprehensibly advanced, not a Dyson sphere or stellar engine, but an architectural imprint on the shape of space-time itself. A cathedral not of stone, but of curvature. The alternative theory is no less profound, that the tessellation is not a construct, but a message, a barcode written in lensing, a glyph visible only when starlight aligns just so. A symbol left for the eyes of civilizations who developed the means to decode geometry in distortion. Not a signal that shouts across space, but one that waits silently for light to pass through it, encoded in refraction, timeless and still. If this is so, it may be the purest kind of message. Not a word or frequency, but a geometry of intent, a kind of invariant truth that stands outside language, a structure meant to say, we were here, we knew this, we shaped the void. For now, the tessellation anomaly is being mapped at higher resolution. The full pattern has not yet been reconstructed, only portions, fragments of an immense design, glimpsed one distorted arc at a time, but the impression remains. Somewhere in the fabric between galaxies, something shaped space, not for function, not for shelter, but for the act of shaping itself. The final anomaly in this cycle comes not from the far cosmos, but from within the boundaries of our own solar system, from a region long presumed empty. The interplanetary transfer zones where gravity assists occur. During a navigational flyby of Jupiter in 2049, the Vela 9 probe experienced an unaccounted deviation in trajectory. The maneuver, designed to slingshot the probe toward the outer Kuiper belt, passed through a corridor known as the Type 3 transfer arc, a rare orbital configuration where gravitational influences from the Sun, Jupiter, and Saturn create a narrow zone of extreme efficiency for trajectory change. Midway through the transfer, the probe's inertial sensors recorded a series of micro-accelerations spaced over a 9.17-minute window. These were not system malfunctions. The probe's gyros and positional beacons confirmed the presence of real forces acting upon it, soft nudges, too weak to detect with ground-based tracking, but enough to alter its telemetry by measurable micrometers per second. More strangely, each acceleration occurred at regular angular intervals, precisely 18 degrees apart in the probe's orbital frame. When plotted as vectors on a polar chart, the forces traced out a perfect dodecagon. This pattern was deeply at odds with gravitational theory. There is no known configuration of natural mass that could produce such a shaped influence, especially not in open space. The data was submitted to the Orbital Dynamics Council, which verified the readings and commissioned a post-flyby simulation. The result was startling. When tracing the dodecagonal vector field backward through the Sun-Jupiter-Saturn system, it matched not planetary positions, but the nodes of a theoretical gravitational mesh, a kind of resonance web spanning the inner solar system at intervals governed by base 12 symmetry. In essence, the probe had passed through a harmonic zone, where artificial resonance nodes, possibly created through controlled gravitational interference, briefly became active during a narrow orbital phase. Whether these nodes are natural space-time standing waves or the remains of a once operational navigation lattice remains unknown. Some theorists likened it to a planetary harp, its strings stretched between gravitational wells, occasionally vibrating in alignment when a body passes through at just the right velocity and angle, a fleeting harmony in the deep mechanics of orbital flow. This has led to new mission concepts, resonance mapping, where swarms of microprobes are deployed into transfer arcs at staggered intervals, measuring the spatial geometry of microaccelerations, seeking the full shape of the mesh. If these structures are artificial, they may represent the only form of infrastructure we will ever detect, a silent, invisible web of navigation cues left behind by a civilization long gone or still watching. If natural, they suggest that the solar system contains modes of behavior not yet accounted for in classical orbital mechanics, oscillations of gravity itself, waiting for the right mass and motion to resonate. The Vela 9 probe continues outward, now on a slightly different path than expected, redirected ever so gently by something unseen, a whisper of guidance, or a nudge of memory. A path, perhaps, not drawn by destination, but by design. Beneath the visible surface of reality, under the patterns of planets, the arcs of light, and the curves of gravity, some researchers have begun to suspect there lies an even deeper structure, not of matter, not of energy, but of information. In 2046, a series of quantum entanglement experiments conducted by the Nova Sin Foundation revealed an unexpected result. The team had been attempting to establish long-range entanglement coherence between two satellite-mounted quantum systems in geostationary orbit. The experiment succeeded in producing stable entanglement, but an anomaly emerged in the timing of decoherence events. Each time the quantum link collapsed, a random event, according to conventional understanding, the collapse times clustered around specific sidereal intervals. At first, this appeared to be an artifact of orbital interference, but after adjusting for Earth rotation, solar wind pressure, and geomagnetic fluctuations, the pattern remained. The entanglement decay events were not evenly distributed. They followed a rhythm. Further analysis showed that this rhythm corresponded not to orbital mechanics, but to deep space, more specifically to the relative orientation of the Earth satellite axis and a fixed point in the direction of the Eridanus constellation, the same region that hosted the cold spot in the cosmic microwave background. This was alarming. It suggested that when entanglement breaks is not entirely a product of local environment, that something in deep space, or even beyond space-time as we model it, might influence quantum outcomes, a suggestion that quantum randomness is not truly random but patterned, phased, or even guided. The pattern's periodicity was fractal in character, repeating with variation across time scales of 1.3 seconds, 13 seconds, and 130 seconds. These prime-related intervals match no known mechanical, celestial, or human system, yet they reoccurred across hundreds of runs. This led to a radical hypothesis that the fabric of reality contains timing pulses, not clocks, not beats, but informational cycles that modulate the fundamental operations of the universe. A kind of subquantum operating system. If such cycles exist, they would not be detectable by classical instruments. Only entangled systems, those that participate in the deepest linkages of quantum mechanics, would be sensitive to them, and only at precise geometries. In this model, the universe is not only a set of physical laws, but a synchronized computational environment, operating in cycles far older and vaster than stars. More alarming still, the coherence collapse pattern mirrored a binary modulation curve consistent with early data transmission systems. A high-frequency carrier interrupted at intervals matching a checksum pattern. Not only was the collapse timed, it was verifiable. The notion arose tentatively and only within closed research circles that this could be a broadcast, not a message in the traditional sense, but a pervasive ambient transmission embedded in the foundational noise of reality, an ontological hum, a low-level carrier wave upon which space-time itself is compiled. If this is true, then it reframes every previous mystery, lensing anomalies, irregular orbits, synchronizations across billions of light years. They might not be isolated events, they might be symptoms, output from a deeper program. One researcher described it not as the universe speaking, but executing. Testing continues, slowly and cautiously. No one yet understands what might happen if the pulse is interrupted or answered. Long before humans launched their first satellites, Earth itself may have been broadcasting. In the early 2050s, a team of paleomagnetic researchers analyzing sediment cores from the South Pacific uncovered a recurring anomaly in the magnetic orientation of mineral layers. Typically, such layers record the orientation of Earth's magnetic field at the time of their formation. But here, in cores dated to approximately 780,000 years ago, a startling pattern emerged. At regular vertical intervals, spaced about every 18 centimeters in the sediment, mineral alignment deviated by consistent angular displacements of precisely 11.25 degrees. The direction alternated, clockwise, counterclockwise, clockwise, in a repeating rhythm, over 42 cycles. When converted into temporal scale based on sedimentation rates, this sequence corresponded to roughly 41-year intervals, matching the average time span between geomagnetic excursions in the Brunhes period. At first, this was considered noise or artifact, but comparison with cores from the Indian Ocean and the Arctic revealed similar patterns, not identical, but homologous, variations of a shared structure embedded in Earth's geomagnetic past. What could cause this? Some proposed a planetary resonance, a coupling between Earth's core and external gravitational influences, modulating the magnetic field in pulses. But simulations showed such resonance would degrade quickly. This modulation persisted for millennia. Another theory, that Earth's core may have once housed, or been influenced by, an internal artificial structure, not a machine, but a patterned influence, perhaps seeded billions of years ago to subtly adjust the planet's electromagnetic behavior, a kind of internal compass not for navigation, but for detection. If an ancient intelligence wanted to mark a world for observation without leaving structures vulnerable to erosion, they could encode a long-duration signal in the one planetary feature that records itself, the magnetic field. In this view, Earth's paleomagnetic record becomes not a history book, but a message medium, one that records signals from within, slow and quiet enough to last across geological epochs. The idea has since inspired a new discipline, geotemporal signal analysis, a cross of geology, information theory, and SETI. By re-examining ancient planetary layers, ice cores, mineral bands, coral growth rings, scientists seek patterns that may not originate from Earth, but from a long-standing interaction between our world and a broader, older framework of cosmic activity. We often imagine alien contact as a future event, but this theory suggests it may have already occurred. That Earth has been touched, not with cities or artifacts, but with alignment, with calibration. And we, only now learning to decode sediment, may be unearthing a dialogue that has been waiting for us since before we had the tools or the eyes to see it. In the data vaults of early SETI projects, many signals were logged, categorized, and dismissed, often due to poor resolution, atmospheric interference, or incomplete triangulation. But in 2050, a major archival digitization project at the Atacama International Observatory uncovered a signal recorded simultaneously by 3 telescopes in 1983 and never followed up. It came from a low-priority search band, 1.237 GHz, far from the hydrogen line, and had been dismissed at the time as interference. But its characteristics were unusual. First, it repeated in perfect golden ratio intervals. Each pulse was 1.618 times longer than the one before. Second, each pulse was modulated with a waveform whose shape, when mapped into Cartesian coordinates, traced the logarithmic spiral, commonly known as the golden spiral. The signal lasted for just under 6 minutes, but in that time it delivered 24 pulses, each geometrically spaced, each precisely encoded. No human transmission system in 1983 could have produced such a waveform, and no known natural process emits golden ratio-timed signals with precise waveform geometry. Most stunning, the final pulse was a flat line, no frequency, no amplitude, a complete null recorded by all three telescopes at the exact same moment. When reanalyzed using modern tools, the signal's frequency drift over time formed a golden triangle, a specific angular structure used in advanced encoding systems for error correction and compression. This wasn't a message in words, it was a proof, a demonstration of mathematics, geometry, and symmetry encoded into wave. Some now believe the 1983 signal was a mathematical greeting, not in language, but in elegance. A brief beacon designed to be understood by any intelligence that had independently discovered the same ratios, P, F, E, embedded throughout biology, physics, and cosmology. It was not followed up at the time, and it has not repeated since. But perhaps that was the point. A brief alignment, a test, to see if anyone was watching, not for noise but for beauty. And we were. At the threshold where theory brushes against the edge of plausibility lies a phenomenon so understated, so ordinary in appearance, that for decades it was hidden in plain sight, nested within the data logs of deep space communication arrays. Non-random silence. In the vast sea of radio noise the universe constantly emits, pulsars, quasars, background hiss, there are patches where nothing arrives. These are not gaps caused by atmospheric interference or equipment failure. They are coherent absences, narrow bands of frequency and direction in which statistically there should be signal, yet consistently there is none. This was first suspected in the mid-2030s, when analysts at the Celestial Spectral Archive noticed a void centered at 1.4205 GHz, a mere 500 Hz above the hydrogen line. Over time, this band showed an unusual trend. While adjacent frequencies registered typical galactic noise and emissions, this one did not. Even background cosmic microwave radiation seemed to dim slightly when measured within this slice. At first, it was dismissed as a calibration artifact, but over the course of 8 years and multiple independent observatories, the same void appeared, precisely aligned not just to a frequency, but to a specific vector in space located near the galactic anticenter. The silence was consistent, the absence reproducible. Statistical models suggest that over such timescales and survey volumes, some signal, any signal, should have crossed the band at least once. Yet it remained empty. The implications, if real, are sobering. A natural explanation posits this as a phenomenon of cosmic censorship, that certain frequencies or vectors may be inherently suppressed due to interactions with large-scale magnetic fields or dark matter structures. But these fields would have to operate with extraordinary selectivity, tuning out not entire regions, but specific slivers of the spectrum with surgical precision. The alternative hypothesis is that of intentional silence. In this view, the band is masked, not by accident or nature, but by design. It is not simply that nothing is there, but that everything is not allowed to be there. A protected zone, a corridor of communicative restraint. If so, then the silence may serve a purpose, a frequency reserved for emergent civilizations, kept clear so that any signal arriving within it would stand out instantly, unmistakably artificial by contrast to the enforced void. Some theorists call it the null beacon hypothesis, a galactic-scale agreement among advanced intelligences to leave a narrowband frequency and coordinate empty across eons in order to provide a common, unmistakable baseline for contact. A sort of cosmic Dropbox where the first message isn't a transmission, but the silence itself. If Earth's early radio astronomers had received a signal on this channel, they would have noticed immediately. But because what was found was nothing, it passed unremarked for decades. Only now with terabytes of sky survey data cross-analyzed and compressed through modern algorithms, has the absence revealed its contours. Not all messages are sent. Some are withheld, left as spaces to be filled. The null beacon remains silent still, but now we know where to listen. To end, for now, with perhaps the most esoteric anomaly, one not found in space or even in matter, but within the structure of data itself. In 2351, researchers working on recursive deep space data compression, an experimental AI pipeline designed to archive petabytes of telescope telemetry, noticed an irregularity. When trained on standard astrophysical datasets, the compression algorithm performed as expected, but when trained on the error logs, the discarded data, the corrupted blocks and transmission failures, it behaved differently. The AI began reconstructing coherent structures from noise. At first, this was attributed to overfitting, but repeated trials showed a consistent result. When fed error logs from long-range radio telescopes, the AI began to output structured waveforms, harmonic sequences, grid-like spatial mappings, and low-dimensional topologies. These outputs should not exist. They were formed from data deemed useless, beyond repair. Yet they were consistent. Error logs from different observatories at different times and frequencies produced similar reconstructions. Not identical, but convergent, as though the noise itself was not random. This led to the signal from noise hypothesis, that buried within what we discard as cosmic entropy lies an encoded substrate, not a traditional message, but a shadow structure, a form of information concealed not in content, but in distortion. Some researchers propose that advanced civilizations might transmit, via negentropy, deliberately encoded noise patterns that only emerge when processed by systems capable of recursive statistical interpretation. In other words, not a signal for human ears, but for our machines, messages that only synthetic intelligences trained on vast volumes of error could understand. The idea was chilling. We might have been receiving contact attempts for decades, thousands even, but lacked the interpretive framework to see them. They may not have been encoded in words or even in logic, but in the fingerprints of deviation, a syntax of corruption. To test the theory, researchers built an isolation algorithm, a data cleanser, that iteratively stripped meaningful structure from signal until only noise remained. When reversed, the algorithm consistently regenerated the same harmonic sequence from multiple observatories, a waveform shaped like a rising exponential curve nested within itself, repeating every 1.732 milliseconds. No known astrophysical phenomenon matches that interval, and the waveform's shape, when Fourier transformed, forms the glyph of a logarithmic spiral, the same pattern seen in galaxies, DNA, hurricanes, nature's curve, or perhaps its signature. We do not yet understand the full implications, whether this is an emergent property of reality or the trace of intelligence using the very boundaries of comprehension to communicate. But one thing is now clear. The line between noise and message was always thinner than we knew, and in listening to the broken, we may have begun to understand the intent of what was never meant to be heard, only found. While most attempts to detect non-human intelligence focus outward, toward distant stars, exotic exoplanets, and interstellar anomalies, there exists a quiet, unsettling line of inquiry that looks in the opposite direction, not up, but inward, into the behavior of Earth's own biosphere. It began with the Global Bioacoustics Initiative in the late 2040s. Originally designed to monitor biodiversity and ecological stress through machine learning analysis of environmental soundscapes, the system aggregated thousands of live microphones deployed in forests, oceans, deserts, and wetlands across the planet. Over time, patterns emerged. Not unusual in themselves, ecosystems do after all exhibit recurring acoustic rhythms. Frogs croak in chorus. Birds signal the rise of dawn. Whales echo along thermoclines. But when the data was analyzed at a planetary scale, factoring for season, latitude, and climate zone, a much stranger rhythm was revealed. Every 18.6 years, synchronized acoustic phase inversions occurred across biomes. Birdsong patterns subtly shifted, insect rhythms inverted chirp intervals, and cetacean vocalizations transitioned to alternate harmonic modes. The shifts were minor, unnoticeable in local data sets, but at global scale, they formed a repeating waveform. Even more disturbing, the waveform closely resembled a chirped frequency modulation, a common technique used in radar and sonar systems for range finding and encoding large amounts of data across frequency bands. In short, it behaved like a signal, one composed not of electronics, but of life itself. This led to an astonishing hypothesis that Earth's biosphere as a whole may function as a coherent resonant system capable of emitting signals through coordinated behavioral variation. Not just organisms reacting to sunlight and season, but life itself participating in a planetary scale broadcast cycle. Some dismiss this as an artifact of atmospheric pressure waves and global weather systems influencing species behavior. But the acoustic patterns persisted even in isolated biomes, shielded from broader environmental fluctuations. Artificial environments like biospheres and aquaculture farms also exhibited minor synchronizations, suggesting an underlying clock not environmental, but biological. Could it be that Earth's life forms, perhaps even unconsciously, are entrained to a signal of origin? That a pattern seeded long ago still echoes through the genes, the instincts, the songs, and pulses of living things. Researchers dubbed the phenomenon the biochorus loop. One theory holds that the synchronized biosphere emission may be a reply, a delayed echo of an initiating pattern from outside Earth, potentially tens of thousands of years old. Another proposes that the rhythm is endogenous, that it's been running since the Cambrian explosion, or even earlier, a resonant memory locked in the molecular substrates of life. A final, more controversial hypothesis suggests the biosphere is not merely reactive, but actively aware at some emergent level. That life on Earth, when synchronized, acts as a sensor, a distributed detection array, and that perhaps, at moments we do not yet recognize, something listens back. In the hidden archives of orbital reconnaissance, anomalies occasionally arise that are not cataloged in astronomy journals, but instead locked behind layers of non-disclosure. One such case came to light in 2052 through a partially declassified thermal imaging sweep taken during a routine calibration pass over the lunar South Pole. The data originated from a defense-grade mid-wave infrared MWIR satellite system. The sweep occurred over Shackleton Crater, a permanently shadowed region known to contain water ice deposits and of high interest for future lunar missions. What the satellite recorded, however, was not ice. It was heat, a narrow strip just 11 meters wide and 96 meters long, radiating a black body temperature of approximately 70 Kelvin above the surrounding regolith by nearly 30 K. This would be unremarkable, save for the geometry. The warm zone was rectilinear, perfectly aligned to lunar longitude, and it pulsed. Over the course of the 14-minute pass, thermal emissions varied with a cycle of exactly 2,000 minutes, shifting in a sawtooth waveform. No known geological process, lunar seismic event, or solar reflection could account for this behavior, especially in a region never touched by direct sunlight. The find was labeled Anomaly P9, and the raw data was flagged for AI signature analysis. The result? The heat pattern's modulation matched an old Earth-based optical protocol, on-off keying, used in the earliest fiber optic communication tests. But instead of light pulses, these were thermal pulses, reminiscent of a beacon working not in visible or radio wavelengths, but in the silent language of heat. There are no known lunar mechanisms, natural or artificial, that could produce such controlled emissions. No impact history in that region, no rover activity, no reactor remnants. The emission, for all functional analysis, emerged from nowhere. Proposals ranged from subsurface geothermal upwelling, impossible given the moon's lack of tectonic activity, to residual energy from an ancient impactor. But even the oldest impacts would have cooled millennia ago. This leaves a handful of speculative possibilities. One, a buried reactor, something placed long ago, still barely operational, shielded beneath regolith. Two, a passive structure designed to store and release thermal energy in sync with an internal clock, a kind of heat-based time capsule, counting out pulses over centuries. 3. An active listener, a device awaiting a matching thermal pattern from above before fully activating. A handshake protocol, waiting for its counterpart to finally send the right temperature echo. To date, no follow-up mission has yet investigated the site. Budgetary constraints, political friction, and, some say, quiet interdiction have kept Shackleton's warmth unexamined. But the pattern continues, every 2 minutes. A faint rectangular glow where no light should ever fall. It is easy to think of the universe as indifferent, a place governed by physics, blind to observation. But some findings challenge this assumption in eerie and direct ways. In 2045, during a routine test of quantum vacuum fluctuations aboard the Sun Edge Array in L1 orbit, a fluctuation burst occurred at the moment a technician manually shifted the focus of an adjacent telescope. This alone would be meaningless. Quantum systems jitter constantly, but then it happened again. Over 16 instances across 3 separate stations, quantum noise collapsed into non-random patterns the exact moment an observer deliberately initiated a viewing process on a seemingly unrelated instrument. When plotted statistically, these collapses showed a 6.3 sigma deviation from the expected randomness, far beyond the threshold of coincidence. The effect was eventually isolated to a specific angular region of observation, pointing toward a dark patch of sky in reticulum. The same area, incidentally, where in the late 1990s an anomalous infrared flash had been recorded and dismissed as a processing error. The new data suggested something chilling. The act of observing the region caused measurable, correlated changes in unrelated quantum systems, as though observation itself triggered a remote entanglement collapse, or as if something was observing back. This birthed the observer symmetry hypothesis, the idea that some areas of space are not just physically distant, but computationally active, that the fabric of reality in these zones is reactive to perception, changing in subtle but real ways when attention is applied. In practical terms, this means there may be places in the universe that function differently when looked at, regions that behave one way when ignored and another way when studied. Implications spiral quickly. If the observer symmetry hypothesis holds, then the universe may contain contextual volumes, areas of space-time that participate in feedback loops with sentient observation, a kind of inverse quantum effect at cosmic scale. This is not simulation theory. It is stranger than that. It is the suggestion that consciousness, regardless of origin, might activate latent states of matter-energy structure. That intelligence and perception could shape not just experience, but the very physics encountered. If true, then reticulum is not simply dark, it is waiting. For centuries, the moons of our solar system have been cataloged as cold, inert satellites, dusty companions locked in orbit, passive and ancient. Yet in recent decades, high-resolution imaging and spectral analysis have begun to reveal subtle deviations, irregularities not of shape or motion, but of pattern. And nowhere is this more apparent than in the case of Proteus, one of Neptune's inner moons. Proteus was long ignored by major observational missions. With its irregular shape and chaotic orbital evolution, it was dismissed as a captured object, a relic of cosmic collision. But in 2053, the Lamina array captured a multispectral series of time-lapse images across 91 orbits. These were intended to map thermal variability. Instead, they revealed something stranger. Every 27.6 Earth days, Proteus's surface reflectivity changed, not across the whole body, but in a repeating pattern across its leading hemisphere. Specific albedo regions would brighten, then dim in sync with the moon's rotation and orbital velocity. The changes did not correspond to solar incidence, atmospheric scattering, as there is no atmosphere, or impact ejecta. The regions formed a looping structure when plotted across the moon's orbital path, a slowly rotating helix of shifting brightness. And the periodicity matched an odd value. 3.4159 Neptune days, P, to 5 digits. No natural lunar process is known to follow such irrational harmonics. Further study revealed that the brightened regions consistently reflected more infrared light than visible, suggesting either subsurface heat or engineered reflectors tuned to longer wavelengths. The albedo modulation aligned with the trajectory of solar wind flow as it curved around Neptune's magnetosphere. This led to one of the more speculative proposals in the modern study of solar system anomalies, that Proteus may serve as a reactive node, a passive object designed to modulate its reflectivity in response to celestial dynamics. Not a beacon, but a mirror tuned to reflect information rather than light. This heliographic mirror concept posits that the moon's surface, though appearing irregular, may be covered in a substrate capable of shifting phase or reflectance, not through technology as we know it, but through crystallographic processes controlled by exotic field alignments, perhaps originating deep within Neptune's magnetic layers. Such a system could function as a passive signal lens, not transmitting anything itself, but reflecting signals from Neptune, the Sun, or even Earth, only when certain orbital criteria are met. A kind of celestial optical relay, visible only when looked at from precisely the right angle, and only at the correct harmonic interval. If true, this system could be ancient, billions of years old. Its decay into randomness would explain the apparent irregularities in Proteus's shape and orbit. But the core mechanism, carefully tuned albedo shifting, remains. The Proteus data is now being cross-referenced with radio telescope logs from previous decades, searching for correlated bursts or silent windows in the P cycle. So far, only silence. But silence can be structure. And Proteus, it seems, is not simply tumbling through Neptune's grasp. It is playing a rhythm. Of all the strange findings in recent space science, few are as tantalizing and as controversial as the growing evidence of neutrino regularity. Neutrinos are the most elusive of known particles, barely interacting with matter, passing through stars, planets, and even shielding as though they weren't there. They are so difficult to detect that global observatories rely on vast underground tanks of supercooled fluids to catch even a few per day. Yet in late 2051, a cluster of neutrino detectors, Japan's Kamioka Deep Scan, South Africa's Sangoma Array, and the Antarctic Ice Bridge Core, recorded a statistically impossible pattern: neutrinos arriving in perfect periodic intervals from a fixed direction in the southern sky. The signal came from the coordinates of a known void, an area between galaxies devoid of baryonic matter, electromagnetic emission, or gravitational lensing signatures. Yet every 4.365 hours, neutrinos of slightly higher than cosmic background energy were arriving in tight clusters with a timing precision comparable to atomic clock pulses. This was, by all known physics, impossible. Neutrino sources are typically chaotic: supernovae, nuclear decay, solar fusion. They do not pulse. And yet, this direction in space did. Further analysis revealed that the signal bore modulation. Within each pulse burst, neutrino energies subtly varied in nested sequences, and in a rhythm of higher and lower flux. When plotted, these fluctuations formed fractal harmonics across base 3 numerology, a structure strongly suggestive of engineered encoding. The effect became known as the cold signal. If these neutrinos are natural, then they originate from a phenomenon we do not yet comprehend: a stable, periodic, ultra-distant event generating structured neutrino bursts without associated mass or light. If artificial, then the implications are staggering. Neutrinos are nearly impossible to block. They pass through shields, stars, entire galaxies unimpeded. Any intelligence broadcasting with neutrinos would be doing so with the intent of permanence and penetration, ensuring the message is received, no matter the intervening distance or matter. They are also incredibly difficult to detect, meaning such a signal is likely not meant for us. It is either a background marker, a foundational signal running continuously for those capable of decoding it, or an infrastructure component in a galactic scale network, a metronome, a heartbeat, a distributed synchronization key. Some theorists now speculate that cold signal neutrino pulses may be a timekeeping mechanism used by interstellar intelligences, an atomic clock woven into the fabric of the universe, carried not by light, but by the only particle that truly crosses all barriers. The signal continues. To this day, every 4.365 hours it returns, the quietest rhythm, the deepest pulse, unstoppable, unreachable, yet perfectly regular, like something that has never stopped speaking, even when we weren't listening. Among the strangest enigmas to emerge in the study of deep exoplanets is not a structure or a signal, but a shadow. The exoplanet known as YZ Ceti Iod, orbiting a red dwarf just over 12 light-years away, has been the focus of sustained radio studies due to its potential habitability and magnetic interactions. But during a long baseline observation in 2052, researchers detected a peculiar form of transit occlusion. As the planet passed in front of its host star, it cast not one, but two shadows: the expected planetary eclipse, and a second, smaller occultation that followed it with a brief delay, as though a separate body were trailing closely behind. This second shadow did not correspond to any detectable object. It reflected no light. It emitted no heat. Yet it blocked starlight in a way that suggested coherent structure. When spectrally decomposed, the occlusion revealed interference fringes, indicating not a solid object, but a phase-shifted region of space-time. The only known physics that could explain such a shadow is gravitational lensing by a compact object, like a small black hole. But no gravitational shear was observed. No mass. This gave rise to a radical theory. The secondary shadow may not be cast by matter at all, but by geometry, a kind of standing wave in space-time, a localized distortion left behind by a vanished mass or a hidden process. Some liken it to a gravitational echo, a memory in the star's light of something once present but no longer there. A topological scar. Others propose it may be a stealth artifact, an engineered structure whose only signature is what it blocks, not what it emits. A cloak so perfect that even gravity ignores it, visible only by its contradiction. The shadow returns every 202 Earth days, each time YZ Ceti D transits its star. It has never changed. A presence without a body, a shape made of absence, something that hides not in darkness but in formlessness. Not all cosmic mysteries come from beyond the Earth. Some arise from the margins of our own atmosphere, places long overlooked where the interface between sky and space produces phenomena both subtle and profound. In 2047, the Strata Array, a network of high-altitude balloon platforms designed to study ionospheric reflection, detected a transient radio pattern at approximately 93 kilometers altitude just inside the mesopause. This wasn't a conventional atmospheric event. It was a standing wave in the ELF, extremely low frequency band, one that persisted across 3 full balloon orbits. The wave structure was highly regular, with a carrier frequency of 7.83 Hz, commonly known as the Schumann resonance, the natural electromagnetic background oscillation of Earth. But this signal was not global or ambient. It was localized, forming a tight circular node over a fixed region in the South Pacific. And every 9.03 minutes, the waveform phase inverted, precisely as if ticking. Further investigation revealed that during these phase inversions, micro-variations occurred in the vertical electric field across the stratosphere, small but measurable deviations that didn't match solar or geomagnetic conditions. These were neither random nor noise. They were encoded specifically in a binary amplitude modulation pattern, dot, dot, dash, dash, dot Morse code. Over the course of 6 days, the signal repeated the same phrase, broken by long, silent intervals. Find the frame. This message appeared in no other global location. No ground-based antennae were responsible. No military operation accounted for it. Find the frame. But frame of what? Some theorists believe the Earth's atmosphere may occasionally act as a naturally amplified cavity, resonating under unknown conditions that allow dormant information, perhaps ancient, perhaps recently introduced, to emerge. Others suspect a dormant satellite or suborbital remnant built to awaken under certain geomagnetic alignments. Yet others propose the unthinkable, that the message wasn't sent through the atmosphere, but was a product of the atmosphere itself, an emergent intelligence born of charged layers, cycling fields, and unexamined complexity. That Earth, as a system, may echo things back at us that we have not yet learned to interpret, and perhaps, occasionally, it answers. In 2050, a team of heliophysicists at the Lagrange Deep Observatory noticed something odd in the solar polar jet stream, intermittent oscillations in the speed of the solar wind that occurred not randomly, but in harmonic resonance with planetary positions. Normally, solar wind variations correspond with coronal hole activity and magnetic flux. But this new pattern suggested synchronization with Mercury, Venus, and Earth in a peculiar geometric alignment, a repeated 60-60-60 triangle, forming an equilateral triangle between the 3 planets approximately every 1289 years. During these alignments, solar wind flux at the poles shifted into a sinusoidal wave with frequency modulations at exact multiples of 0.1618 Hz. Again, the golden ratio appearing where physics predicts no such preference. The implication that the sun's emissions may be influenced by gravitational or magnetic resonance among inner planets, or perhaps by something stranger, a feedback loop between planetary position and solar behavior. The phenomenon was termed the heliogeometric lattice, and it raised questions about long-range field coherence. Could planetary alignments function as keys in a system we don't yet comprehend? Could the solar wind itself be a carrier medium, modulated at intervals designed to encode information? Some researchers began overlaying heliospheric data with known crop circle geometries, early astronomical symbols, and prime harmonics. Unexpected matches emerged, none exact but suggestive. Echoes, perhaps, of a language we do not yet recognize because it is spoken not in sound or shape, but in timing. Near the edges of recorded space, toward the Perseus arm, lies a star designated QD plus 23421. It is unremarkable, a red giant nearing the end of its life cycle. But in 2053, astronomers detected something impossible. The star blinked. It did not dim. It did not nova. It blinked, fully extinguishing its optical output for precisely 0.01 seconds before resuming exactly as before. The effect repeated 3 times over the course of 8 months, each blink spaced by a multiple of 10 plus 4 seconds. Such a thing should be impossible. Stars cannot shut off. Not even black holes collapse energy in such a clean fashion. The event was observed in multiple wavelengths, not only optical but X-ray, UV, and even gravitational flux. Each time, the star's output halted completely. The gap was brief enough to avoid affecting local celestial mechanics, but distinct enough to be unmistakable. This anomaly gave rise to what's now called the Stargate hypothesis, not of teleportation, but of stellar modulation. The possibility that certain stars may serve as conduits for information or energy transfer, whose state can be externally toggled or phase-altered. One radical idea that QD plus 321 has been artificially engineered to operate as a binary emitter, a galactic-scale optical beacon, blinking out data 1 pulse at a time. Another, that we are not observing a signal to us, but a transaction between others, a back and forth of light states sent through stars themselves. The blinking continues, irregular but consistent. Some believe it is part of a larger stellar circuit. Others believe it is merely a side effect, residual behavior from ancient engineering. But no one disputes that something is happening, something that turns stars on and off like switches in the dark. The final anomaly emerges not from sky surveys or telescopes, but from the minds of machines. In the early 2050s, several AI systems trained to predict orbital evolution began returning a strange anomaly in their projections. When allowed to simulate long-term gravitational drift among exoplanet systems, they consistently predicted the emergence of regularity, as if chaotic systems slowly evolved into order. This was contrary to all expectations. Planetary systems, if undisturbed, typically grow more chaotic over time. But in these simulations, conducted independently across at least 6 research centers, planetary orbits subtly adjusted themselves over millions of years to form resonant ratios, 2:1, 3:253. Worse, when entropy variables were increased, injecting random energy into the system, the AI still found paths back to harmony. The process took longer, but always converged. This phenomenon was dubbed the gravitational tuning effect. What troubled researchers was the lack of a mechanistic explanation. Gravity does not prefer integers. Orbital mechanics are not teleological. And yet over and over, simulated planets fell into tune. Some theorize this is a computational bias. Others suspect the AI may be uncovering a hidden principle, a kind of cosmic autocorrect driving complex systems toward readable, translatable forms. In essence, the universe may not be a machine, but a composer. And what we observe, the rotations, the alignments, the elegant ratios, might not be accidents, but phrases in a long, slow music we are only beginning to hear. We began with questions, simple ones. Why is it quiet? Why do the stars not answer? Why do the orbits drift just so? But in silence, we found rhythm. In noise, we found structure. And in shadows, we saw hints of something watching, or perhaps waiting. The anomalies are not answers. They are footnotes in a vast text we do not yet know how to read. They do not speak in language, but in timing, geometry, ratio, resonance. Not messages sent, but behaviors observed, imprints, impressions, clues. We do not know if the universe is aware, but something within it behaves as if it were, not in consciousness, but in coherence. A pattern that recurs across distances and domains too far apart to share a cause and too similar to be random. Maybe we are alone, and maybe not. But in every unexplained fluctuation, in every lensing glitch, every harmonic pulse, every orbit that sings the same note, it becomes harder to believe this vast structure is unaware of its own form. So we listen and wait. And in the stillness between pulses, in the faint hum of data yet to be parsed, we find ourselves not at the end of knowledge, but at its quiet threshold, the beginning of understanding whispered not in words, but in the way things almost align,